Hello? Conseguem ouvir-me?
Perfeitamente.
Okay, so I'm gonna share my screen. Can you all see my screen?
Yes.
Yeah.
Yeah.
Okay.
Yes.
So welcome to the online pitch of the Client Solutions track of Energy Starter. Glad to be here today. It's gonna be an intense day. I'm just gonna do a very brief presentations, like 2 minutes, and then we go to the first pitch, okay? So just gonna go quickly through the project timeline, the structure for today, and the lineup, so the startups that will be here today. Going to the timeline of the project. So we already closed the applications, right? And evaluated the startups that applied to the program. We selected 41 startups to be here today. The online pitch is going to be today and tomorrow. And today we're going to have 20 startups pitching, and tomorrow we're going to have 21. So it's going to be intense, but super interesting. So after this phase, we may have some follow-up meetings with startups in order to clarify some questions you may have. And then we're going to select specific startups to go to the bootcamp that's going to take place in Lisbon from the 3rd till the 5th of December. And then we have an ongoing phase of the project, which is the pilot development. Then, speaking of today's structure, we're gonna be here for 4 hours. So take your bottles of water and keep your energy going. So as I said, like each startup is gonna have a 10-minute slot, okay, to present. So 4 minutes to pitch. We're gonna have a timer here. It's gonna make noise when it stops. It's a different system this year. Then we're gonna have 4 minutes of Q&A. And there you can either write the questions you have in the chat, or you can unmute yourself and just ask them to the person who's gonna pitch. And then we just have a buffer of 2 minutes just to make sure that everything is on track in terms of schedules. And then the lineup for today. So these are the startups that we're gonna listen to. So we are gonna have 20 startups today, and 3 breaks in between. So the first one is Elstor Oy, and they're already in the other room. They're ready to join us. And I don't know, before starting, Vasco, I don't know if you want to say something.
No, I think that's it. Yeah, just feel free to ask questions at the end of each pitch. And in the meantime, we'll ask you for your feedback regarding each of the startups, but I think Margarita has already said everything. So yeah, we're right on time. I'm ready to start. So let's go.
Yeah, excited. Okay, so gonna stop sharing, and we can already, João is the administrator here, so João, you can call the first startup. So it's gonna be Kari presenting Elstor Oy. Hi, Kari. Welcome.
Thank you.
Welcome. So we are here in the pitch room with DDP, and go ahead and share your screen, and you have 4 minutes to pitch, okay?
Okay, let's see if this works out. Let me know.
Yes, you can, yeah.
You have full screen?
No.
Uh,
We can see the presentation, but it's not in full screen.
Okay, all right. Thank you. So we have a solution where we have been able to replace, in a commercial cases, steam generation from gas and oil to heat thermal energy storage for emission-free steam. Okay, now I should change the page. We have doctors and professors behind our company, and the idea started from the fact that storing electricity in the traditional electrochemical batteries is not the most economical way, and also it's not sustainable. So something else is needed to store electricity. So we came up.
Can you put your thing on presentation mode because it's smaller?
Okay, because I have it here on a presentation mode. Let me try again. We had the same challenge when we joined it. Let me see what happens here.
Yeah, just try to reshare, Kari. Should work out.
How about now?
There you go.
Thank you so much.
Yes.
Okay. Okay, now I have a challenge to switch the page. That's my problem here. This is the Zoom challenge. Yeah, I'm not able to change the page now. This is a problem. Yeah, it doesn't work. So I need to stop again and try again. Oh, let's see what happens. Any better now? Not full screen.
We are seeing the presentation, but maybe it's better to continue like this because in full screen you can change. So yeah, go ahead.
Okay, sorry about that. All right, so we came up with the thermal energy storage where we store electricity in the form of high temperature. We have optimized the storage temperature level to 500 to 600 Celsius degree, and we discharge with steam and heat. Every customer case is optimized what is the right storage size and what is the right charging power. We have been able to basically replace our food and pharmaceutical customers' steam generation from gas and oil with the lower cost than they had earlier. So they have saved cost. And we have up to 20 megawatt hour storage size. And then if the need is bigger, we have multiple units next to each other. 85% of our target market, we can meet this temperature level.
Sorry. Kari, are you moving forward? I mean, I'm freezed. I don't know if this is only me, but I'm freezed on the first page.
Yeah, that's also me.
Yeah, I'm on other page. Yeah, this really technically doesn't work. Let me see what happens now. Now I have page number 3. How about you?
Yes, we can see in full screen page 3.
Okay, all right. So this is what we have come up with, and now we have nine delivery contracts. We have four in operation, and the oldest one 3 years, and basically the reliability and the cost reduction targets have been achieved at each customer. Okay, but I'm not able to switch the page now. Sorry, I need to get off this now. Stop sharing again. Yeah, this is not good. Let me see. Okay, now I have page number 4. Okay, but do you have now page number 4? Okay, so basically, with our commercial cases, we have been able to achieve all these 5 benefits. Customer has got emission-free steam with our storage up to 98% energy efficiency from electricity to steam. Depending on case, steam profile, we have been able to achieve good payback time for customer or for us. Then demand response, our national grid company in Finland has been extremely happy with our solution. This fits perfectly to the grid balance control. And then the 5th benefit really was a good surprise for us that our customers' workforce has been very happy with our solution because it's changed their life very much when they got rid of boilers, gas and oil boilers. So we have 2, I don't know, I changed the page. I don't know if it worked for you, but we have 2 solutions. So we have, we sell the technology or we do steam as a service. And this steam as a service has been a good way to lower the
Kari, I'm sorry to interrupt, but we can't see the other page. Yeah, right, if you can. Yeah. Okay, now we see page 5. Okay.
Okay, you see it when it's not in a presentation model. Okay, let me now take another page here. Oh, this is really not good. Okay, and then.
But yeah, maybe you can show the slides after in the Q&A and so on. So yeah, go ahead.
Okay. All right. Now I don't know whether you see the page number 6. Here we have our references. So we have been delivering to food industry, industrial district heating, also pharmaceutical. Biggest pharmaceutical company will replace their gas and oil steam generation with our technology. So the oldest one is 3 years in operation. Okay. All right. So basically, maybe this where I will end. Basically, now we have technical and economical means to combat this challenge of climate change and in steam generation. And the most attractive segments for us is food, beverage, pharmaceutical, also industrial laundries and chemical industry. And regarding target markets, Nordic, UK, Netherlands, Belgium, Ireland, France, Spain, and Germany currently is our primary target.
Kari, yeah, so we ran out of pitch time. So now maybe we're going to go to the Q&A. Yes. And you can share, like, maybe if you have, you can share your slides if there's something if there's any question related to it. Okay. So who has questions here for Kari?
So I have a simple question is what's the medium and what's if you can give us an indication of cost?
Yeah, okay. Of course, I cannot reveal all the details, but we started with molten salt. Then we recognized their benefits and negative sides. Then we made a generation 2, which is not molten salt. It's a solid material structure. And now we have generation 3, which we have delivered. And all these deliveries are with this generation 3. It's a solid material structure. I think that's all I can tell currently. I cannot reveal all the details. Okay. The cost-wise, first of all, the target was to store electricity with a cheaper solution than traditional electrochemical batteries. So we have been able to achieve 3 times cheaper the cost than Tesla's biggest industrial battery. Maybe the cost-wise, what could I say? Let's think about 10 megawatt-hour storages. We talk about cost about 1 million euro currently, but we have certain plans to reduce the cost.
Okay.
In the future.
Clear. It's clear. Just give an indications. It's okay. Thank you.
Yeah.
Can you hear me?
Yes.
Sorry, not sharing the video because I'm a train, but one very specific question. What's the ratio between charging and discharging? Meaning, how many hours of charging do you need per day to complete charge the battery?
It fully depends on the case. We optimize based on the case. We have always asked customer to give the last 12 months steam profile in a minute or 1 hour basis, and then we calculate the optimum sizing regarding the storage size and charging. We can, of course, if we increase the charging power, we can fill it in 4 or 5 hours. And regarding electricity price volatility market in Nordic, that seems to be the optimal.
And how do your existing customers source the energy to charge the battery?
Sorry, now I didn't hear fully.
How can you hear me?
Yes, yes.
How in the contract that you have active, how is the energy sourcing being made on those customers?
Okay, basically all electricity is renewable, and of course it's taken from the grid. But if there would be a customer with a lot of solar panels on the roof, that can also be utilized, but it's taken from the grid. Was that your question?
Yeah, but do you take the risk and you sell the steam to the customer?
Yes.
Or does...
Yes, yeah, we do steam as a service, so we basically do it all. Customer only need to stop their production for 5 hours when we connect our system to their existing pipeline, and that's it. And we take care of everything. We build it, and we buy the electricity, and we charge for the steam. And we handle the demand response to the grid companies.
Okay. And in which countries are you commercially active?
Currently, we have been only delivering in Finland, but we have now inquiries also in Central Europe, and now we are planning how to do it.
Okay, thank you.
I need to say that we were in a climate conference in Dubai in December, and McKinsey got really interesting on this. And basically, they say that we are number one or number two regarding number of commercial references. Okay, I don't know what is the truth, but at least we have a lot of experience.
Mm-hmm. Thank you.
Thank you, Kari. Thank you for your presentation, for being here today. We'll let you know the results in the next few weeks, okay?
Sure. All right.
So,
thank you.
Thank you.
Yeah, bye-bye.
Bye. Okay. So next we are going to have Akon from Cartesian AS presenting.
They should be joining right now, Margarita.
Okay.
Hello.
We have Alexis. Hi, Alexis.
I'm waiting for my colleague Håkon.
Oh yeah, he's here. Yeah. Okay, both of you are here. Okay, so welcome. We are in the pitch room with EDP and we are ready to hear your pitch. So yeah, you can go ahead, share your screen and start. You have 4 minutes.
Great. Well, good afternoon. I'm Håkon Sarnes.
Sorry, can you put it in? Yeah, perfect.
It's coming.
Thanks.
Right. Okay. Good afternoon. I'm Håkon Sarnes. I'm the co-founder and CPO at Cartesian. We are in the business of thermal energy storage, delivering energy when you need it. To address climate change, we of course need more renewables, and to make that possible, we need to balance the supply and demand of energy in a better way to avoid large investments in the electricity grid. And all this leads to higher volatility in the electricity pricing. You know, when you see these high prices in electricity and even negative pricing of electricity, this is what creates the incentives for energy storage. Cartesian offers compact thermal energy storage technology simply because heating and cooling constitutes more than half of the end use of electricity in buildings and other sectors. Thermal energy storage is a better way and more sustainable way to store energy for building applications than electrical batteries. Our thermal box, as we call it, helps owners of commercial buildings to reduce their operating costs for heating and cooling by reducing the energy consumption, peak power requirements, and improving their carbon footprint, all packaged within a package that gives the less than 5 years payback time. Commercial buildings, like office buildings, supermarkets, and shopping malls are our sweet spot in the market. It's a multi-billion market in Europe alone, growing with 7% annually. And our value proposition in this segment here is 30% less peak power requirement during the peak hours of the day, and up to 20% energy cost reduction for heating and cooling systems. Cartesian was established last year on the backbone of 10 years of R&D at Sintef Energy Research in Norway. Our solution relies on the fascinating storage capacity that is phase change materials, reversible and everlasting cycle between solid and liquid of a material that stores the energy. We have now 4 reference installations in place. One of them has been 3 years in operation. 3 of them in our home market in Norway, while we will commission the one in France next week already. Key to all of these installations that we have here is the possibility to reduce the size of the heating and cooling systems and also store thermal energy when electricity is cheapest and most available. We envision a pilot with EDP as a good opportunity to showcase our solution to one of the key markets of Cartesian, cooling for commercial buildings in the European market. We believe that our technology can be unlock flexibility in building sector and be used as an asset in new business models such as cooling as a service and participation in the power reserve market. A pilot with EDP would involve then identification of a site, installation, implementation with a technical partner, and then documenting the performance through collecting data, analysis, and see the impact on the end user site, while simultaneously offering a balance to the grid with 2 years or less in this market. This is our team with a broad experience, and we're commercially driven and a strong track record. We are in business, and we want to make more impact with energy when you need it.
Thank you. And thank you for respecting the time and thanks. So now let's open for Q&A. Who here has questions?
So maybe I can, thank you for your presentation. Just one question, can you clarify this? Like, is it, so your system can do both cooling and heating at the same time, or is it you're shaving the cooling need and that's how you're saving that? I didn't quite catch that.
Yes, we have the same architecture. We switch out the phase change material, and then we can apply this to heating and to cooling, but it's 2 separate systems. Biggest impact we can do with cooling.
And do you need to maintain a certain amount of energy for this phase change material to not solidify completely?
Sorry, can you repeat that back again?
I was saying that, do you need to maintain like some sort of energy input at all times for this phase change material to be active?
This can be left for months without use and then reactivated. There's no requirement of maintenance of an energy level in the phase change material.
I can maybe, I guess you think of molten salt, and here we use the phase change. We do convert the material, from liquid to solid and reversibly back to liquid. So that's what we do to store the heat or the cold in that case. So it's not like molten salt. We use the phase change in that case. So yes, it converts fully from liquid to solid and then back to liquid again.
Okay, thank you.
But sorry, from what I understood, the actual heating and the actual cooling is done by another asset, another production unit, and then you're essentially storing that heat or cool to be used at peak hours or during to avoid those sorts of times. Is that it?
That's correct.
Perfect. So essentially, what type of assets are you working with?
Typically, you mean other, what is the thermal, providing the thermal heat? Typically, yes. This is with heat pumps, big market in Europe, transitioning away from gas boilers, etc. And then with having a storage, it gives you a possibility to reduce the needed investment in the heat pump to cover the heating load. So you cover peak hours with the storage.
It's clear. Thank you.
What is the size of your unit for a megawatt system? Whatever system you have in mind, what's the size?
Our sizing now is we build modules on size of a Euro pallet, so 120 by 80. So it's transportable into buildings, and then you collect them together to the size that you require. We have the biggest one that we have delivered is up to 800 kilowatt hours. So then you scale according to need and demand.
But the Euro pallet what's the capacity of the Euro pallet?
For cooling, it's up to 125 kilowatt hours per unit, and for heating using PCMs, it's about 75 to 80. Depends on the PCM.
So that's 1 Euro pal,
Yeah, 1 unit.
What kind of temperature range is?
So I guess you mean the whole range of temperature we can cover. So we have applications between -20 degrees and +120 degrees.
But the key, let's say the key market is cooling for buildings and heating for buildings. So then we stay between 0 degrees and 80 degrees, let's say. That's the core temperature range.
Okay, thank you.
We ran out of time, so thanks a lot. I can connect you, and we'll let you know the results in the next few weeks. Okay.
Thank you very much.
Thank you.
Have a good afternoon. Good luck with the pitches. Bye.
Thank you. Bye. Okay, so next we have Miguel from Build to Zero. João, you can let him in.
Yes.
Hi, everyone.
Should be entering.
Hi, Miguel. Great. Okay, so we are here in the room with VP. You have 4 minutes to pitch, so go ahead.
Okay, thank you. Well, good afternoon, and thanks for giving us the opportunity to present our company to this EEP Energy Starter program. Build to Zero is a company that develops electrothermal energy storage technology and has a proprietary product called Thermal Box that has been specifically defined and designed to decarbonize industrial heat. Today, we are 18 people that are mainly focused on product development, leveraging all our experience after 15 years in the solar thermal industry. Build to Zero, at Build to Zero, our mission is to address the critical climate challenge of the industrial sector. Since there are more than 25,000 terawatt-hour of energy that needs to be decarbonized to meet the net zero target by 2050. According to the last report submitted by Breakthrough Energy and Systemic, the market for low medium temperature is in the range of 8,400 terawatt-hour. And if we focus on those industries that can be easily decarbonized using renewable electricity, such as food and beverage or paper, the market potential reaches in the range of 4,000 terawatt-hour. But to do it possible, it's needed an urgent scale-up of easy-to-deploy technologies able to compete with gas boiler. And this cannot be done today without grants or subsidies. And thanks to this specific deployment, we will be able to compete with them. To solve this problem, we have developed a solution that is efficient, scalable, and cost-effective. This solution is called Thermal Box and is completely different to other alternatives that there is in the market, because it's based in the beauty of simplicity. How it works? Well, we use renewable electricity to heat up molten salt from 180 to 400 degrees. Then we send by gravity this hot molten salt through the steam generator to produce the steam, and the remaining salt are stored to be used later on. And we only need 3 connections with the industry, so we ensure a seamless integration to our clients. Today, we have standardized 2 solutions, one for 2.5 and 5 megawatt thermal of capacity, for 14 megawatts hour thermal and 28 megawatt thermal. At present, our Thermal Box is able to compete against gas, considering a gas cost of 35 euros per megawatt hour and 70 euros per ton of CO2. All this considering the 40% subsidy in CapEx that is being received, for instance, here in Spain from the Next Generation Fund. However, we expect to reach cost parity by 2028 based on manufacturing efficiency and also on that standardization that we are following in our product. On top of that, we can also generate additional revenue stream by providing secondary reserve services to the grid, because our system can provide that for free. The pilot plan we are suggesting here is to develop in collaboration with EDP a first-of-a-kind project in the food and beverage or paper industries to showcase and demonstrate the potential of our solution in the industry. Our proposal is to install a 2.5 megawatt thermal box with 14 megawatts hour thermal of storage to deliver 3.5 tons per hour of saturated steam at 20 bar maximum in a 24/7 basis. The optimal configuration that we are pursuing is to have a 3 megawatt PV solar plant to deliver 85% of the total electricity that we need to consume in our system, while the remaining 15% of the electricity will come directly from the grid. Our partnership with EDP is based in 3 main points. The first is to collaborate to secure a first-of-a-kind project in the food and beverage industry, preferably dairy, or in the paper industry, either tissue or cardboard manufacturing sectors. Partner with EDP to implement the solar PV requested to feed, electrically speaking, our system with a 3 megawatt peak PV plant, and co-develop and optimize the dispatching software that we are already implementing in collaboration with Google Cloud to optimize the use of the electricity while providing the thermal demand. And we don't need any financing from EDP because we already got and secured the funding from the European Innovation Council. So it's just a matter of closing the project in these sectors to cooperate and to demonstrate how innovative and profitable is our solution. Thanks for your attention, and we'll be delighted to answer any questions.
Thank you. So now let's go for Q&A. Who here has questions for Miguel?
I have a question. What's the levelized cost of storage that you have on that unit without power?
Without power, you mean?
Yes, without power, just meaning the value of storage. Because you mentioned that you had finance, so what's the levelized cost of the solution? Or if with power, which price of power are you considering in the business case?
Yeah, the levelized cost of the storage is in the range of 40 euros megawatt hour, and the price for the steam that we are pursuing with this combination is in the range of 60-65 euro per megawatt hour.
So you are assuming that the cost of power around 20-something euros.
We are able to capture this range of prices, pursuing this combination of grid plus PV, based on this CapEx subsidy. Yeah.
You are assuming that will be subsidizing. There will be subsidies on the PV plant.
Yeah.
Okay. And what's the amount of the subsidy for the PV plant? Is the 45%?
It's in the range of 30 to 40. It depends on the combination and the size. Yeah.
So that value for power will be achieved on the mixture of the as a service for the PV plus the subsidy that will be discussed on top of that.
Yeah. Otherwise, Otherwise, you can close just the base load on the power side, and then just to get the subsidy on the storage part.
Okay, it's clear. And you are the customer, or do you have a customer ready for that?
We already have a customer in the chemical industry that the project is being developed, and now we are willing to get the customer in the paper or in the food and beverage sector.
Okay. So basically, you are searching for a partner to do the PV and the power from the grid.
Absolutely right.
Okay.
Some last question? No? Okay, so
can you hear me now? Can you hear me?
Yeah, we can.
Oh, sorry, because I was disabled. Thank you, Miguel, for your presentation. Following the questions that my colleague Antonio asked you, because for me it wasn't clear, the LCO at from between 60 and 65 is with or without the subsidies?
Today is with the subsidy.
With the
Today
subsidy.
is with the subsidy, yeah.
Considering the 30 to 40% of subsidies.
Yeah, okay. That's right. But at the end of the day, it depends on the demand profile that we have, the use of the PV, and the number of hours that we need to include in the storage. So it's not a unique answer. It depends on the case. So we optimize this in a case-by-case analysis, thanks to that dispatching software that we have developed. So this will allow us to optimize the design, the number of hours of storage, and also the optimal PV that we need to optimize the final cost of heat.
It's clear. just one last question. The plant that you said that you already have a client, which is the power of the thermal unit?
Is 2.5 megawatt thermal with 14 megawatt hour of storage.
Okay. Clear. It's under construction, under project signed.
Is under construction at this moment. So we have 12 months in front of us to complete the project and start the commercial operation.
European project or
European project, a Spanish project. It's a project in Spain.
Okay. Thank you so much, Miguel. It's clear.
Welcome.
Thank you, Miguel, for being here. Thank you for your presentation, and we'll let you know the results in the next weeks, okay?
Thank you for your time.
Thank you.
Bye.
Bye. Okay. Yeah, okay, so now we're gonna have Dolph from AtmosZero Europe. Sure, you can let him in.
I have to leave. I was just I have just booked for this presentation, but I don't know, Antonio maybe is traveling, but I will catch up with him. Thank you.
I'm here as well, Sophia.
Oh, sorry, didn't saw you.
Okay, so do we have the AtmosZero Europe here already?
Yes.
Yeah. Okay. Hi, Dolph and Roll. Hi, welcome.
Hi.
So we are here in the pitch room with EDP, and we are ready to hear your pitch. So go ahead and share your screen, and you have 4 minutes to pitch, so you can start.
Great, thank you.
We can see.
So can you see my screen?
We can.
Awesome. So, hi everyone. It's great to be here. My name is Dolph Jukus, and I'm excited to talk to you today about steam. So some 250 years ago, we learned how to harness the power of steam and kickstarted the Industrial Revolution, arguably the main driver behind the explosion of wealth and the increased standards of living. Today, because it is such a great heat transfer medium, steam is still 50% of all industrial heat. But because making it is typically done by burning fossil fuels, it's also a major greenhouse gas emitter. So in order to keep our planet livable for future generations, we need to decarbonize steam. Now, electrification is emerging as the winning strategy, but current solutions really fall short, either because they have high running costs, like e-boilers, because they have a large footprint and low efficiencies, think thermal energy storage, or because they have high integration cost and aren't scalable, like waste heat-driven heat pumps. So at AtmosZero, we're developing the solution to these problems, and we're developing them now and not in 10 years. So please meet Boiler 2.0, a modular, low-cost, fit-anywhere replacement for steam boilers. Because it is a heat pump, Boiler 2.0 has up to twice the efficiency and so half the running cost of e-boilers. And because it is air-sourced, the installation is much faster and much simpler, resulting in a lower capex than waste heat-driven heat pumps. Boiler 2.0 really is a product, not a project. And the $30 million that we've raised at AtmosZero to date from EIP and other leading investors in this space has allowed us to build out a world-class team, and the market has already started to take notice. So we're proud to have signed up several early adopter customers. And we're deploying our very first Boiler 2.0 unit in the US in less than 6 months from today. So what's next? Well, deploying in our key market, which is Europe. And as we take our product to market, building out the AtmosZero Europe team that I lead. We want to partner with players like you, EDP, who deeply understand their industrial customers' need for decarbonized steam and that want to offer a solution in the near term. So we propose to do a 6-month commercial demonstration of our Boiler 2.0 unit in 2026 at an EDP customer site in Europe. It's going to be fully supported by AtmosZero. All the learnings will be shared with EDP and its customer, positioning you as the leader in decarbonization of steam. So please come and meet our fast-growing team and visit our lab and manufacturing facility that you see here in Colorado, US. Together, we will identify and analyze a customer site. We'll get the commercial agreement in place and build, ship, install, and run a Boiler 2.0 to help your customer save energy and eliminate Scope 1 boiler emissions from day one. So what are we waiting for? Full steam ahead. And I'd be happy to answer any questions you might have together with my Senior Application Engineer Europe, Roel Arts.
Thank you so much for the presentation. Yeah, let's go to the Q&A. Who wants to start?
Hi, thank you for the time. I was just trying to confirm that I fully understood the technology. Essentially, you're combining a heat pump that's heating up water to up to 80-90 degrees C, and then you're using resistive heating of that water up to whatever temperature and pressure you need for industrial process.
No, that's not correct. Actually, the entire unit is a cascaded heat pump. So we use heat pump technology, vapor compression cycles to go all the way up to steam, essentially.
Okay, understood. And you do it with a COP of around 2.
Our target COP is 2. And what we see for our first customer in the US is we're gonna, with this pilot system, we aim to have a COP of 1.6.
Okay. Do you see this system? Is there a theoretical maximum beyond the 2 that you could do? Are you planning on, or do you see it, or this is a technological break where you can't do more than 2?
At the end of the day, the fundamental limit is the Carnot efficiency, and a practical device of this scale and this lift will cap out somewhere like 60% of the Carnot efficiency. But with COP2, we're already going to be quite close to that. If we reach COP2 at 150 C steam from 15 C outside air, we're going to be close to what other market parties with heat pumps can achieve. So, yeah.
Okay, my next question would be the sourcing of the electricity. Are you is this something that's up to the customer to source? Is there any and beyond this, what's sort of the flexibility of the actual unit in terms of moving up and down and reducing or is this a very stable where you're delivering a continuous amount of steam and you really can't move up and down that quickly? It's a question of how fast can you respond to?
Sure, it's a question we get more often. So in theory, a heat pump is ideally suited for baseload.
Yeah.
But we are getting these requests quite a lot for flexibility. So we are investigating and testing the flexibility of our heat pump system. We do know that we can operate at a certain turn down and the transition is fairly fast, so a matter of minutes. But this is something that we want to develop further. And to your first question about electricity sourcing, we typically tie into the regular customer's electricity supply. So if they would need help, if that is your question, to source like a PPA, we'd be happy to help them with that. But in principle, we just take whatever electrical capacity the customer has available at the site.
Okay. One last question would be if you could give us an indication of the levelized cost of heat.
Sure. We believe that we can offer the lowest levelized cost of steam compared to e-boilers because we are way more efficient, and compared to waste heat driven heat pumps because our capex is so much lower. What we see in the market is that our other waste heat driven heat pump systems, the total capex of the project can be up to 4 times the cost of the equipment, of just the heat pump equipment. So that's why we believe we can offer the lowest levelized cost of steam, and obviously the exact number depends on the cost of electricity that the customer is facing. Yeah.
Okay. Thank you for your time, Dolf and Roel. We'll let you know the results in the next few weeks. Okay. Thank you for your presentation. And
thank you so much.
Bye.
Thank you. Bye-bye.
Okay. So next we are gonna have Wei from Heatrix. So can let him in. And after this, we're gonna go for a short break. So bear with me. Hi, Wei.
Hello. Hi, everyone.
Hi. Welcome. So we are here in the pitch room with EDP. You can go ahead and share your screen, and you have 4 minutes to pitch. So
great.
Go ahead.
Thank you. So you can see if it works. I hope you can see everything.
Yes. Yeah.
Right. Okay. So, hello everyone. My name is Wei. I'm co-founder and CEO of Heatrix, and our mission is to replace fossil fuel burners with renewable electricity to decarbonize industrial process heat. We are addressing mainly 2 challenges of EDP within client solutions, and that is, first of all, electrification of industrial heat and air, and energy storage and flexibility. Let me introduce you to one of our industrial partners, a family-owned brick manufacturing company in Germany. Brick manufacturing is highly energy intensive. They need a lot of energy to produce the heat to burn the bricks. And they are facing several challenges, like raising CO2 costs, which leads to higher energy costs. They can't really play ahead due to volatile fossil fuel markets, and green alternatives are still very expensive. And at the end, their own customers also want to have green products. So their main question is actually, how can I decarbonize my processes? Well, we have just the right answer. Our solution converts renewable electricity into carbon neutral process heat. Our system consists mainly of an electrical air heater that works basically like a huge hair dryer that uses electricity to heat up air up to 1500 degrees C. And we combine the heater with the thermal energy storage to make sure that heat is always available whenever it is needed. To ensure the lowest costs possible for our customers, we also provide a smart control system that optimizes the storage operation based on real-time forecasted energy data and pricing. The control system can also provide valuable consumption data for the energy provider to optimize its own energy management. Our system is completely modular. That means we can serve smaller scale applications up to large scale processes, always with the same modules. Our approach is about retrofitting existing furnaces and not building new ones. So in order to decrease the downtime of the plant and also decrease integration costs and risks. However, one major challenge remains for our customers, and that is the access to green electricity. We are therefore proposing a pilot project with EDP where we want to offer heat as a service for European SMEs. That means that customers does not buy our hardware, but rather the heat it produces. For that, we'd like to have an energy partner on board who provides renewable electricity and may also offer heat as a service to the customer. In the first phase, we can identify together a suitable application, industrial partner. Then we will design and build the Heatrix system according to the requirements, and we will also develop the smart control system based on EDP's feedback. We also like to collaborate on the legal terms, providing heat as a service. And during implementation and operation, we will monitor the system performance and also derive improvements from those results. And after the successful piloting, we would like to explore further opportunities with EDP on how to take our collaboration onto the next level. We expect a duration of about 12 months for the project and about 600K to cover hardware costs and also staff costs. Our vision is to build a virtual heat battery network around the globe where we can have multiple heat clients powered by renewables connected across the network. We believe that those networks are essential for a future energy system as they increase the energy management and while efficiency and resilience are also increased. We invite you to make this vision reality with us, and I'm looking forward to our next steps. Thank you for your attention, and I'm happy to answer your questions.
Thank you, and also for respect the timing. It was great timing. Okay, so now let's go for Q&A. Who wants to start?
I can start with some questions. Thank you for the pitch. So what is your expected cost for the solution, and how do you compare with similar bricks solutions out there in the market for thermal storage?
You mean expected cost for the hardware or
for the solution as a whole?
As a whole,
you're charging as a heat as a service. So how do you charge per unit of heat?
That's highly dependent on the renewable electricity price we get. So that's, I don't know if you expected that's how it determines the heat cost as well. So we can have efficiencies around 90%. So if you can assume electricity costs of roughly 60 euros per megawatt hour, for example, then we can charge heat costs for roughly 70 euros per megawatt hour. Just to give you an idea how that is converted.
Your levelized cost. Yeah. So your system costs you around 10 euros?
Sorry?
So the levelized cost of heat would be the levelized cost of storage would be around the 10 euro per megawatt hour.
Well, that totally depends on the electricity costs we can get. So just if you have like 60 euros per megawatt hour as an input, then it's roughly something around 70 euros. Yeah.
Okay.
But if you go with higher electricity costs, then you would also have higher.
No. So that's why we're asking levelized cost of storage. So yeah, that's independent of the electricity that's being consumed. By the difference, we are assuming between 60 to 70. It's a 10 euro cost and those 10 euros per megawatt hour cover the cost of the storage units that you're building.
Yeah, roughly.
Okay, what sort of medium are you using?
It's air. So air is the heat transfer medium, and the storage material itself is ceramics. So we plan to go up to 1500 degrees C. So we have modular, different kind of materials. So in the lower temperature, it's more like concrete, high temperature concrete, and then above 600 up to 1500, it's like high temperature ceramics, alumina based ceramics.
May I ask what's the like the retrofit time for these kind of factories? And like, have you already done some kind of tests on that?
Sorry, what was the first question?
Have you done some kind of tests on retrofitting of the factories?
Yeah,
How long it takes?
so we're currently building 3 pilots in different sectors, one in bricks, one in steel heat treatment, and the other ones is on drying. And we are currently setting up the first pilot, and that's going to be ready early next year.
What's the capacity of that pilot that you're planning to have?
That's a really small scale system, so it's like 50 kilowatt, and the storage has like 200 kilowatt hours.
Okay.
And will you be testing like those 1500 degrees Celsius ranges in that pilot, or is it going to be a lower temperature test?
No, in that pilot, in that first one, it's a drying application up to 400 degrees. For the bricks, it's going to be 1200.
Do you have a minimum temperature you need to maintain in the system for it to be efficient?
So our sweet spot is between 300 and 1500, basically, if that answers your question.
That does, yeah. Thank you.
Good, thank you.
Okay, so thank you so much for your presentation. We'll let you know the results in the next few weeks, okay?
Yeah, thank you. It was a pleasure. Bye-bye.
Bye. Okay, so now let's go for a quick break. Okay, let's be back in 7 minutes. Okay.
Okay.
Hello. Okay, so the next speech, it's going to be Jeffrey presenting from organic heat exchangers. João, you can let Jeffrey in.
They should be joining right now, Margarita.
Okay. Yes. Hello.
Hello.
Hi, Jeffrey and Bob. Hi, welcome.
Well, thank you. Good afternoon.
Good afternoon. Hi, we are here in the pitch room with EDP, and we are ready to hear your pitch. So you can go ahead and share your screen and start presenting. You have 4 minutes.
Okay.
Yeah, we can see it.
Can you see that? Okay. Good afternoon, everyone. My name is Jeff Barker. I'm a director of Organic Heat Exchangers, a UK developer and manufacturer of EnergyVault, an innovative cold thermal energy storage technology. As most of you all know, energy storage is an essential requirement to achieve our goal of net zero, and cold thermal energy storage is a hugely underutilized approach to this. I'd like to explain why EnergyVault should be selected for a pilot for EDP. Just setting the scene, the industrial and heavy commercial refrigeration markets, specifically the chilled water markets, has an installed base of more than 2 million installations worldwide, these being greater than about 400 kilowatts of cooling, and annual chiller sales of more than 10 billion a year. And this industry has 3 key drivers at the moment: ever increasing cooling demand across the world, the need for sustainable solutions, and greater use of connectivity and data and AI for improved control. The challenge for such industrial chilled water systems is a general lack of operational flexibility. You tend to find most of these sort of systems will have some modulation, but their true flexibility, being able to switch on and off and having some kind of energy storage to be able to affect that effectively is not present in most of those 2 million or more systems. In particular, data centers, which we'll point to for the pilot. Dealing with AI processing now has more and more short-term fluctuations in cooling, as well as and generally limited with any form of capacity management, although some of them do have buffer water storage tanks. Problems with grid capacity constraints have also create problems for data centers. And energy storage and cold energy storage specifically can help flatten these cooling demand curves. Energy Vault can help with this. Energy Vault is a very attractive solution to this for cooling flexibility. It can be applied to chilled water systems with more than 400 kilowatts of cooling capacity. The Energy Vault system comprises a thermal battery charger and thermal battery, which stores very tiny ice crystals, each battery storing around about a megawatt hour of cooling capacity, around about -3 degrees. And the system is monitored via monitored and controlled via our Energy Vault platform, which interfaces with a local controller and BMS and our predictive AI controls. The system delivers an optimized charging and discharging functionality through this mechanism. And the four main benefits that you can see on the screen here: reduce energy costs and carbon through management and flexibility services provided alongside the chiller, increase chiller capacity for peak cooling and high transient cooling applications, and flexibility. Importantly, increase the resilience, which we've seen on our full-scale system demonstrator, which we've had on a site, a UK pharmaceutical site now for about 14 months up in the northeast of the UK. Providing backup, optimizing existing chillers and added resilience. Energy Vault is different to other cold thermal energy storage systems, typically about 8 times greater energy density than chilled water. Doesn't have any of the, has a high energy density compared to chilled water and similar to solid ice, but doesn't have any of the limitations. Obviously, electrical energy storage doesn't allow you to have that additional capacity for cooling. So Energy Vault offers the opportunity for EDP to address one of its main challenges, that obviously of energy storage and flexibility, within a market of more than 2 million existing installations and growing at more than 5% a year. It will provide its end users, customers with many untapped benefits, augmenting chillers and with greater flexibility, peak capacity, and resilience. We propose a pilot project adding Energy Vault systems to a data center, combining EDP's renewable energy supply and data to deliver and demonstrate benefits which can be rolled out into this huge energy-consuming data center market, whilst also demonstrating value propositions to the wider chilled market. Organic Heat Exchangers will propose a collaborative team, including EDP, data center operator, and local refrigeration HVAC service companies. The project will start by assessing cooling demand, allowing it to accurately size an Energy Vault system, and then integrating it with the cooling systems with one of the data center modules. You probably know that data centers consume 2% of the world's electricity. So Energy Vault can help in this growing industry, adding flexibility and resilience. I think I'm nearly out of time, just about. So I'll just leave you with this sort of one statement, that we believe Energy Vault is the only affordable, flexible thermal energy storage solution available in the market today. As I said, whilst chilled water is generally used small amounts as buffer storage in data centers and elsewhere, and storage is used in small applications where it's quite niche, the ability to provide real flexibility and high responsiveness and dynamic cooling, we don't believe is in the marketplace today. Thank you.
Thank you, Jeff. Thank you for your presentation. So now let's go for Q&A. Who wants to start?
Let me kick off with a couple of questions, and thank you for the presentation. Have you implemented these so far? Can you guide us through what an implementation looks like? With whom have you partnered with to have this joint offering between energy, your system, to a data center provider? Is this something that you have tested before? How that would look like?
No, we haven't installed a system with a data center, which is the reason why we're sort of proposing it as an EDP pilot. We've installed it, as I mentioned, in a pharmaceutical site in the northeast of the UK, predominantly for air conditioning and humidity control, and that's been connected to our platform for optimization, so it can predict what energy is required, cooling energy for the following day, charges the system and discharges it. But we haven't obviously installed this in a data center. That's obviously our objective is to do that with yourselves.
If I could just add to that, the data center was picked out by us because we're working with a large data center manufacturer in America at technical feedback level at the moment. But they shared with us that they have horrendous peaks of temperature that generally the water chilling system that keeps it all cool can't manage. What I think is worth mentioning is as well, the common denominator in this technology is chilled water. So it's not isolated to data centers, but personally in our company, we would love to see the reaction upon a data center, because our thermal battery rated at 1 megawatt hour or multiplex on that figure can discharge at huge discharge rates of thermal energy. So it wouldn't be out the way to actually expect a 2 megawatt power peak out of a 1 megawatt hour thermal battery. And we defy anyone on the planet to manage to melt 11 tons of ice in 30 seconds. And that's where we become a very unique option in the flexibility of thermal storage. I hope that clarifies our position.
Clear.
One question. Does your solution include the chillers as well, or just the storage part itself?
Well, the Energy Vault system comprises two parts: the battery charger, which is a refrigeration chiller in its own right, but it's a unique design which crystallizes a working fluid, and the storage element, the thermal battery. So the chillers that we perhaps referred to in the presentation are the existing chillers that might be as part of a data center, or chillers that are part of, as in the case of our example demonstration site, on a pharmaceutical site. So often there's an existing pack of chillers, and you will basically add on an Energy Vault battery and charger to that system in order to provide that additional capacity.
Okay, so your system still needs to take in cold, or can you take in electricity and produce all the cold?
Yes, obviously it's an electrically driven thermal battery charger, which is a refrigeration device which crystallizes a small quantity of fluid, which is then stored in latent heat. That latent heat and cold chilled water is pumped to a heat exchanger, which is an interface between the cold battery and the chilled water system. So quite happy to send you some further information after this call, just simply explains that. But our Energy Vault system sits alongside an existing chiller and chilled water system and interfaces to it, providing additional cooling support. But as Bob said, at very, very high rates and responsiveness of cooling, which other chilled water or thermal energy storage systems just simply don't provide.
Yeah, got it. Thank you.
Thank you so much, Jeff and Bob. Thank you. We'll let you know the results in the next few weeks. Okay.
Thank you.
Thank you.
Thank you. Right. Okay. Okay, so now we're going to have Marta from EnergyNest. Hi, Marta.
Hi, can you hear me?
Hi, yeah, we can. Hi, welcome.
Thank you.
Okay, welcome to the pitch room. We are here with EDP and we're ready to hear your pitch. So you can go ahead and share your screen, and you have 4 minutes to pitch.
Okay, give me a second. Can you see?
Yes.
Now we can,
yes.
yeah.
Okay. So thank you very much to EDP and BetaI for giving us the opportunity to participate in this program. So since I need to stick to the time, I will go directly into one of the key points of the energy transition, okay? The decarbonization of industrial heat. In this graph, we can see that from the world total energy, 1/3 of it is consumed in the industry sector, and 2/3 of this is consumed in the form of heat. Considering that 90% of this heat is produced from fossil fuels, we can state that heat is responsible for 55% of the CO2 emissions in the world, okay? And if we land this to the Spanish market where I'm based, the industry represents 21% of the gas emissions compared to 10% of the electricity. What I want to say with this is that there is a huge amount of thermal demand subject to be decarbonized, okay? So in EnergyNest, we contribute to boosting this decarbonization. And just to a quick introduction, we are a company founded in Norway in 2011. We currently have offices in several countries in Europe, and we have a few projects in execution. Okay, so how can we contribute to decarbonize this heat? Okay, what's the solution to this problem? What we propose it's an electrification of this heat with thermal storage, okay, using renewable energies. So like this, we can ensure reliable energy supply, offering a flexible and fast response solution made of abundant materials like steel and concrete that support the circular economy. Here you can see the core of our technology. Okay, it's a module made of steel and high-performance concrete with a piping where the hot fluid flows, transferring the heat to the concrete where the storage really takes place. Okay, it's simple, it's modular, it has no degradation. The lifetime can be 25 or 30 years easily, and it has negligible OPEX. So actually the thermal battery itself has no maintenance, okay? And we are talking about round-trip efficiencies up to 97%. So what we propose is a pilot to electrify these thermal processes in any of these industries that we can see here in the slide that have thermal needs in the range of 125 to 360 degrees and annual gas consumptions above 10 gigawatts hour per year. Of course, for pilot, this can be lower, no? With this, we can reduce CO2 footprint, we can reduce the dependency on natural gas prices and volatility, and optimize the assets' energy efficiency, integrate the renewable energies, reduction of energy cost and grid fees, and also generation of additional income by market participation. So just to see a concrete case, this is how our system looks like. In this case, we are proposing a 6 megawatt hour thermal battery with an electrical heater and a steam generator. The aim is to cover an annual thermal demand of almost 9 gigawatt hour per year with a steam demand flat of 24/7, charging in 2 cycles of 6 hours each, with a solar plus wind PPI. In this way, we can cover 100% of the thermal demand, okay? If we talk about CapEx, this is something to look into details, but we could be talking about 700 or 800K for an EP solution and 1.5 to 1.7 million for a full turnkey solution. And the project duration from the moment everything is defined until project execution is finalized, it can be around 15 months, okay, due to the delivery of the equipment. So to wrap up, why should EDP partner with EnergyNest? We need to incentivize the demand. I think I ran out of time, no? And motivate the final customer. So if we bring together the expertise of EDP and ours, we can achieve this huge decarbonization of thermal demand.
Thank you, Marta, for the presentation. So now let's go for Q&A. Who wants to start?
Yeah, I would like to make a question, Marta. I would like to understand the efficiency of the cycle.
In this case, we are talking about electrification because we have other applications like waste heat recovery or steam balancing. In this case, we have an electrical heater, which efficiency it's almost 100%. Okay, and the thermal losses associated to our battery are around 2%. Okay, so if we would charge the battery completely and don't use it, due to thermal losses, it will lose at 2%. That's why we calculate around 97% round trip efficiency.
Okay, thank you.
Welcome.
2% per day or 2%?
Per day.
Hi, Marta, one question. Do you have an estimate on the CapEx? Let's say for a 10 megawatt hour system, roughly how much?
In this case, it's a 6 megawatt hour storage. Everything included, if it's an EP solution, it's around 700 or 800K. If we go for an EPC solution, so everything installed, commission and everything, we are talking about 1.5 or 1.7 million.
Okay.
It's a 6 megawatt hour solution?
Yes.
Okay.
It's true. This is there is how do you call it? Potential of a scale. So the larger the system, the lower the capex per kilowatt hour installed, okay? But here we are talking about a small project. So the prices per kilowatt hour is higher.
Regarding to your pilot proposal, Marta, do you have any business case associated to this scale or some figures we can analyze?
Yes, actually, this is something that we presented to EDP some time ago, 1 or 2 years ago, with the innovation team in Lisbon, and we have some other use cases in this range.
Okay, it would be good, at least for me, you can share with us a small business case or a small exercise with figures, trying to understand the costs of the electricity, the consumption, and the LCOAs.
Sure.
Okay, thank you.
Welcome.
Some last question?
Yep, maybe I can ask you that. So, like, what kind of, how many hours have you had the prototype testing already, like, for certifications and so on?
Well, you're asking how many hours we have had a project running?
Yeah, like running hours of a typical product of EnergyNest.
So we made a pilot already back in 2015, and this was operating for almost 2 years. Okay, and then it was partially dismantled to run some post-mortem tests, and now we will finally dismantle it. Then we have another project in operation, which is not electrification. It's only charged with steam and discharging steam at lower pressure. This has been in operation for more than a year already. And then we have another 2 under construction and commissioning, but they haven't been running. I don't know if this answers your question.
It does, actually. So in the second part, like, may I ask what's the temperatures that you're maintaining with the steam? So the input is steam, and then you're adding something to that, or you're just like providing that whenever needed later?
Yeah, no. So we produce the steam in the heater, in the electrical heater or electrical boiler. Actually, what we propose normally, we work with oil. We heat up the oil. This is what charges the battery. And then we have a steam generator to produce the steam. But we don't need additional energy supply to heat up the steam.
Thank you.
Okay, we ran out of time. So thank you, Marta. Thank you so much for your presentation. And we'll let you know the results in the next weeks. Okay.
Okay. Thank you very much.
Thank you. Bye. Okay, so next we're gonna have Megan and Patricia from CarbonCapture. Okay, we have Kenny. Hey, hi, Megan. I can't hear you.
Still no.
Okay, yeah, works.
Okay, perfect. Sorry, probably just speaking a little too quietly.
Okay, welcome. So we are here with EDP, and we are ready to hear your pitch. So you can go ahead and share your screen, and you have 4 minutes to pitch.
Perfect. Let me just put this into presenter mode real quick. Okay. All right. My name is Megan Kenny, and I'm the Senior Director of Strategy and Projects at CarbonCapture Inc., a direct air capture technology company and project developer. The world needs to decarbonize, and quickly. The IPCC suggests that even in aggressive decarbonization scenarios, carbon dioxide removal, or CDR, will still be required to meet the 1.5 degree scenario. Estimates suggest that this could require up to 10 billion tons of capacity per year of direct air capture or other CDR methods by 2050. Further, while companies like EDP have defined plans to decarbonize their assets and operations, challenges still exist across the value chain. To start with small customers, less than a quarter of their annual emissions come from energy use. Subsequently, while fully renewable power will go a long way to addressing emissions, These customers have to find other solutions if they want to be net zero. Larger customers, like Google and Microsoft, have seen their emissions grow despite net zero targets as new industries outpace their decarbonization plans. Further, as customers with significant buying power, their outsized energy needs often mean that smaller companies are left unable to procure low carbon generation. At the governmental level, just using the US as an example, huge gaps remain. Many states have not defined realistic, actionable plans to reduce their emissions. Finally, at the developer and utility level, we've seen intermittent renewables outpace long-duration storage. This has resulted in gigawatts of surplus renewable power that could have otherwise been used. Oops, wrong way. All of these problems are areas where utilities, developers, and CDR companies like CarbonCapture Inc. can fill a need. There are many ways in which EDP and CarbonCapture Inc. can work together, but to address the energy starter challenges in particular, EDP could strategically pair DAC with its assets to offer customers lower carbon power or potentially even net negative power in certain areas. Depending on how much carbon removal we want to develop together, the DAC scope could run on new renewable generation, existing EDP assets, or on only surplus power available. Surplus power alone in the US has the potential to result in millions of tons of annual carbon removal, emission savings that can be passed on to customers. To start, we envision the work with EDP in 3 different stages. Step 1 is a desktop exercise and analysis to fully size the opportunity in different energy scenarios and outline what the offering will look like to customers. We will also need to overlay EDP assets with different storage opportunities. This step can also be used to understand what other technologies could be paired with DAC, such as heat pumps, to even further the overall benefit. From this initial analysis, we can define a rubric to narrow down the short list of potential project options. Step 2 is the actual engineering study to generate all the detailed calculations, drawings, and cost estimates needed to decide on deployment. And the final step, assuming the thumbs up from the teams at EDP and CarbonCapture, would be construction and operation of the actual pilot deployment in the field, as well as the rollout of the customer product offering. I won't spend too much time here, but to go over a little of our background and ability to execute. We were founded in 2019 and have grown to nearly 70 employees. We've raised $90 million to date and have pre-sold approximately 27 million in carbon removal credits for our upcoming projects. In June, we unveiled our first full-scale module publicly and are on track to build and deploy 4 more as part of a commercial demonstration in Q1 of next year. That demonstration will generate carbon removal credits for our early customers. We're also thinking ahead. In sum, I believe this team and DAC in general has an important role to play in EDP's future toolkit. I'll stop there.
Thank you. Thank you, Megan, for the presentation. Thank you for respecting the timing. Okay, now let's go for Q&A. Who has questions?
And if I can just say really quickly, my colleague, Patricia Luria, our VP of Business Development, is also on the line for Q&A as well.
Okay, great.
Thanks, Megan. Maybe I can go first. So just something to make clear, or maybe you can give me a range on this. What's the energy intensity on your capture for the moment?
Sure. So this will change over time because sort of the underlying strategy for us is developing a systems approach that allows us to replace the sorbent or actual capture material inside over time. And so right now, that number is around like 1 megawatt per 2,000 tons, but we expect this to come down significantly over the next 3 to 5 years, probably by like 50% or more.
Right. And like is it like a modular solution that you're offering, like so scaling up? And so if so, like,
yes,
what's the tonnage?
Yes, yes, exactly. We do have a modular solution. Our module is about the size and form factor of a shipping container. And that system, the one that we unveiled in June, has the capacity of about 500 tons per year. They can also be stacked on top of each other to reduce the overall footprint that's needed.
And what's your current cost of capture? And I understand that's a very good question, dependent on where you are and so on. But like, what kind of ranges do you see falling as well? I mean, I understand it might be high right now, but in the next 5 years, what do you see the fall rate of that capture cost?
Sure. I will say yes, very sensitive to where we are. And I would say from an OpEx point of view, at least, it is most sensitive to the price of energy, price and carbon intensity of that energy. Right now, we are seeing costs that are closer to like the $700 to $1,000 per ton, but have projections to take that kind of sub 300 to 400 within the next couple of years in our models, if not significantly lower.
Right. And so if you had to give a percentage to the contribution of energy cost to this number, what would that be, or in the range?
I should know this number off the top of my head now. In terms of energy from an OpEx perspective, I think the last that we had seen was probably up to even like 20 to 25%. It is a significant contributor, the cost.
Thank you.
And I guess to provide a little bit of frame of reference, to date, we have been assuming that we would have a grid connection in most instances. And so we have typically been somewhere between like 8 to 12 cents a ton in most of our models that we've used so far.
Right.
Ideally, would love to get it a lot lower than that.
Well, ideally, everything should be in Quebec, and then it should be nice with hydropower, I guess. Yeah. Thank you.
I have a question. So in the projects that you have running, what are you guys doing to the carbon that you capture?
Sure. So in the first module that we released, we do not actually have a storage medium right now. It was mainly for technical demonstration purposes. However, in the commercial demonstration that we'll be standing up early next year, we are looking at a couple of different options. We're in conversations with a number of building material developers. So we'll do like mineralization into concrete or aggregates. But we are talking to a number of Class 6 well operators who plan to have their wells up in sometime next year. The system will have liquefaction on the back end of it, on the back end of the DAC modules that will allow us to truck to different off-takers. But ideally, in the future, we would like to be kind of co-located with the end use so that we don't have to truck.
And in the US, that's Class 6 wells. Obviously, in other markets, they're defined differently.
Yes.
Okay. Thank you so much, Megan and Patricia. We'll let you know the results in the next few weeks. Okay. Thank you for being here today.
Thank you very much. Have a good day, everyone.
Bye. Okay, so the next startup, we're going to have Tammy Sang from Plentify.
Good afternoon all.
Hi, Tammy Sang. Hi, welcome.
Thank you so much. Really appreciate the opportunity.
Thank you. So we are here in the room with EDP and we are ready to hear your pitch. So you can go ahead, share your screen, and then you're going to have 4 minutes to pitch.
Perfect. All right, then I'll jump right into it. I don't want to waste any time. If I could just share my screen. There we go.
Okay, yeah, we can see.
Awesome, we're together. Amazing. Good afternoon, everyone. Thanks so much for the invitation. My name is Dumi. I'm Plentify's growth associate. One of our co-founders was actually supposed to pitch today, but unfortunately got stuck in a train. So I'm here to help out today. So I'm just going to dive into it over here, right? So as you all obviously know, there's been a global energy crisis with spiraling tariffs and unreliable electricity supply. And that's kind of borne out what Plentify is trying to solve. So in the South African context, we're a South African company founded in Cape Town. And last year, South Africa suffered more than 6,000 hours of load shedding, which is rolling blackouts for those that are not familiar with the term. We're suffering rates of tariff increases that are increasing 4 times the rate of inflation since 2010. And as a result of that, we're seeing a very high penetration of solar in the residential space. So we've got a real penetration of about 6% so far. And obviously, the problem that comes from that is that now you're generating a lot of electricity when it's not being used. You still got those big peak demands in the mornings and evenings. And we propose that we can actually shift demand from appliances to basically match supply and demand for 75% cheaper than batteries. So we'll take all of those shiftable appliances in the peaks and try and shift them into the middle of the day as much as possible when solar generation is available. How we do this is through an intelligent home energy management platform, right? So we basically help optimize and automate how homes use energy through load management without any guesswork. And we power this platform using our bots, right? So we've got Hotbot and SolarBot, Hotbot for your electric water heater, and SolarBot, which connects to any residential inverter. And they can basically talk to each other wirelessly and build all of those loads into the middle of the day as much as possible. SolarBot basically does this by making sure that we allow the battery to drain as much as possible during the mornings and evenings, and then we've got as much capacity as possible to basically charge up the battery using solar. And additional to that, we're connecting more appliances to solar. So whenever there's enough or excess load, then we'll basically allow your water heaters, your pool pumps, etc., to turn on to use as much of that electricity as possible without having to curtail it. And then Hotbot, similarly, like I mentioned, it's for the electric water heaters in particular, which basically makes them significantly more efficient. And we've also built some really cool features like best-in-class leak detection. So basically, SolarBot and Hotbot promise to have wide-scale benefits for the energy system. We've proved this for Hotbot on its own through Project Smart Geyser in Cape Town. And we're proposing to basically do this with both devices at the same time. And this could have wide-ranging benefits for both the utilities, basically giving you a fully installed virtual power plant of home appliances, and the users or the residents will receive all of the benefits in terms of cost savings and being able to install more solar into their homes. We basically identified Spain and Portugal to be the perfect entry points for Plentify's platform and for this pilot, mostly because there's around 8 million electric water heaters across the 2 countries. From our research, we've seen that EDP alone has installed more than 100,000 solar systems in those 2 markets. And the other problems, like we've mentioned, the higher cost of electricity, and also the greater incentivization of self-consumption, right? So that obviously went into effect in 2019. And in this pilot, what we're proposing is that we want to develop, or rather deploy 500 Hotbots and SolarBots across 500 homes to prove the technical and financial feasibility, giving the residents all of the benefits that I highlighted before. Obviously, we chose Portugal and Spain, as I mentioned before. And as I mentioned, EDP is basically gaining a fully installed virtual power plant for virtually no additional cost. Thank you.
Thank you. Thank you, Amazing, and thank you for respecting the timing. So now let's go for Q&A.
Amazing.
Who wants to?
Maybe I can start. And thank you for the pitch. So just to clarify, what you need from EDP is basically the availability from our customers to install these 500 units. And then something else, or just to make sure what would be our responsibilities and yours in managing the VPP?
Yeah, that's a great question. Thank you, Andre. So that is effectively what we are looking for. So it's access to these 500 homes. Like I say, we're a South African born and bred company, but we do have global aspirations. And we believe that this would be the perfect market to really prove that this type of technology can benefit a utility like EDP.
Okay. I think Ugo has a question here in the chat. Maybe
in the chat. Let me see.
We have a question.
Hi guys.
I see it here.
So my question is regarding the Hotbot. I would like to understand if it can be connected to any electric water heater already installed on the customer house. And if so, if it's not going to interfere with the warranties, since these equipments are not built to have this start and stop mechanism.
Yeah, very good question. So firstly, yes, it can be connected to any electric water heater. So it's agnostic to those types of water heaters. It just doesn't work with things like heat pumps and all of those other types. And then in terms of warranties, we actually have been in discussions with geyser manufacturers, insurance providers, and such. And obviously, in the South African context, we might need to do it in Europe as well. But they typically don't interfere with any warranties because the installation is very simple. It's not particularly invasive. Just a couple of very simple temperature sensors. Even the thermostat is not particularly tampered with. So yeah, there's no real worry about voiding any sort of warranties.
Hi. Hello. Can you hear me?
Loud and clear.
Can you explain a little bit better how the business model will work? Because I mean, you are going to install this in the client, but then how you are going to manage this through a VPP? Because I mean, we at EDP also sell electricity to our clients, so we need to participate in the market. How your solution will somehow be coordinated with our market participation as well, in order to do not create deviations from our side.
Perfect. Can I just play back what I'm hearing, just so that I'm sure that I'm answering the right question? So you're trying to understand the business model and how it's actually going to benefit EDP and not just the end users, in a
Exactly.
nutshell. Okay, perfect. So in terms of benefiting the EDP, so you as a utility, you're obviously looking at moving towards a more, a cleaner grid or a cleaner generation. So that's your solar, wind, and the likes. What we're basically saying is we can allow you to build bigger solar plants, bigger renewable capacity, without fear of having to curtail that load. Because obviously, as you obviously know, the biggest problem is you install all of these amazing megawatts of production, but there's nowhere for these loads to go, right? So we're saying we're going to basically create as much of a load sink using batteries, water heaters, and other household appliances that don't need to be on when the user's using them. So that'll give you a lot more flexibility in terms of demand response.
Okay, so you are not going to, to take that flexibility on your end to the energy market. So this is still on our side.
Yeah, it's predominantly on your side. I guess time's up. Yeah, I'll just finish up my thought there. But yeah, I guess there could be multiple ways we look at it if you're looking at arbitraging and other types of models like that. Yeah.
Thank you.
Okay, thank you so much, Sami-san. Thank you for your presentation, and we'll let you know the results in the next few weeks, okay?
Perfect. Appreciate the time, everyone. Have a lovely afternoon.
Thank you. Okay, so next, and before the next break, we're going to have Xuan from Emulate Energy. Okay, hi, Xuan.
Hi, how are you guys?
Hi, welcome.
Thank you.
So here we are in the pitch room with EDP, and we're ready to hear your pitch. We can see your screen. Can you put it in full screen mode? Yeah, okay, great. Okay, you have 4 minutes, so go ahead.
All right. So firstly, thank you for the opportunity. I'm going to start off by kicking in a big open door. Electricity retailing in Europe today is not really attractive. You have high competition, you have profit margins that are at best at break even, and you have high churn rates. At the same time, there is a clear opportunity being opened up with distributed energy resources that your customers are buying and installing in their homes. We've seen in Sweden that it opens up value creation pools that are 85 times what the average profit per customer is today. We demonstrated that in Sweden, and that's what we sort of drilled into and differentiate on our journey to grow the company. The product we offer electricity retailers is an integration into the mobile apps, which allow their customers to link all types of distributed energy resources. The first thing we do is really to start optimizing the consumption of these things given the exact tariffs that are on, including demand charges from the DSOs that are being rolled out. But at the second step, which is really where we differentiate, we aggregate these connected loads and we facilitate the integration into the trading desk of the balance responsible party. And this is where we differentiate ourselves from the competition. The core technology is a direct continuation of my co-founder's postdoc at MIT. And essentially, it maps the flexibility of thousands of devices, all subject to human behavior and with their own internal control logic, into something that's easy to integrate into the operations of the utility companies and perform multi-market trading in different energy markets. Today, we're the market leader in Sweden. We're working with 20 plus utilities. We are expanding not only in Sweden, which is our home market, but also in US where I live. And we also gotten into Germany and the Austrian market. In total, we contracted the loads of 29 megawatts that we slowly ramping up and rolling out. What we see as a potential pilot with EDP is to really go beyond smart charging. We would like to see how would different business models based on flexibility look like for EDP's residential customers. Essentially, what we've done in Sweden, how can it be replicated given the conditions that you see in Portugal and given what the conditions that you have on the energy markets there and the uptake of DERs? I'm a little bit ahead of schedule, but let's open it up for questions in case there's anything that needs to be cleared up.
Yeah, great. Let's go for the Q&A. Who wants to start?
Hi, Juan. This is Jorge. Please, could you elaborate a little bit on your differentiation from competitors? You were mentioning on the integration. Could you elaborate a little bit?
Yeah, so what we do is we essentially help you to connect to your customers' distributed energy resources, and everything that gets connected, we map the flexibility into a battery specification. So you would essentially interface these devices as if they were collectively a battery. So we have an API integration into your trading desk, and your trading desk would be asking us, what is the virtual battery I have available for this specific market during this time period? We would do an inventory downwards into all the connected devices. We would pick the ones that would be compatible with the market that you're requesting, and we will be deploying the optimal control strategy for the conditions in that market. We will give you a spec back, and you would tell us, your platform would tell us what to do with the virtual battery, what times to charge it and what times to discharge it. We would execute the downward commands and then provide you with the data you need to settle it on the different markets. So our thing is really not smart charging necessarily, but integration on an aggregate level of EVs, heat pumps, charging stations, batteries into your trading desk and allow your algo trading platforms, if you have that today, to sort of perform the market optimization. Does that answer the question?
Yeah, I think so. This is running automatically.
It's all automated, yeah. So it's an API-based product. We have actually published that on our website, so you can go and have a look at it there.
And what's your business model? So it's like a software as a service, and you sell your API per consumption. Is it like that?
Yeah, so we have three revenue streams. The first revenue stream is a platform fee that we charge on a monthly basis. It just ticks. The second fee is based on number of users that are connected, and the third fee today we're doing in Europe, in Northern Europe at least, we're doing a revenue share on what gets generated on the electricity markets. In US, we deploy a fixed dollar per kilowatt that we make available in the virtual battery for trading.
When you say number of users, it's not number of assets. It's by individual.
Yes, exactly. Number of assets. Exactly.
Okay. Yeah. And from the 29 megawatts that you have, what's the type of assets that you have connected within those 29 megawatts?
So most of that is actually the largest fast charging network in Scandinavia. That's the biggest that we have. We've also gotten into commercial batteries, which is the second biggest. The third biggest is a few thousand residential loads that we've connected. So I would say the vast majority of the 29 megawatts, the easiest way to quickly get scale and expose these devices into the markets is really to go with if you're a charge point operator, or if you have batteries or your customers have batteries, that's the easiest way to ramp up capacity. The big thing we see coming up right now is batteries for residential loads. We're making a big push there, and I anticipate us going live with at least 3 utilities in Sweden during the coming months. We're in the final sort of pre-launch phases.
Arnaud, you want to say something?
Yeah, thank you, Sean, for the presentation. Just like 2 questions. Are you acting as a balanced responsible party in the Nord Pool market, or is it being done by someone?
So we're not. We integrate into the balanced responsible parties trading desk, but we help them pre-qualify the loads for ancillary service market. So we have several loads right now that are providing ancillary services in the Swedish market that we control. But technically, it's the balanced responsible party that's trading with it, and we want to keep it like that. We don't want to go in and sort of challenge and take business from the incumbent utilities, including the balanced responsible parties.
Right. And which markets do you tap into, like FCR or FRR or
FCR? We are into. We are FCRD, FCRN. We are right now looking into intraday markets, which is the big move that we're making next, because the ancillary service markets are going to start saturating, and we see that there's going to be a need to diversify the trading, and it's a journey.
Right. That would have been my next question, but okay. Thank you for that.
Sure.
Thank you so much, Juan, for your presentation and for answering our questions.
Absolutely.
We'll get back
again, but in a nutshell, it goes beyond smart charging. We want to see what can you do on the energy markets with it. Okay. Awesome, guys. Thank you for the opportunity.
Thank you.
Thanks. Bye-bye.
Bye. Okay, so next we're going to go for a short break, and let's be back in 9 minutes, okay, for the next round. Okay, see you.
sácatela, 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 sácatela. Cuando tú giras la cabeza va buscando otra polla. Eres amoroso y es la polla, pero te comerá como una chupacabra. Sácatela.
Historia, una broma, ayúdame a sacarla de mi cabeza.
Sácatela, 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 sácatela. Yo te lo digo, tío, tienes que olvidar a esta tía. Para los amores del mundo, de tu pobre corazón, de tu cordura. Sácatela.
I can't decide. Your love is sending me round, thinking out loud. Baby, come, let's get down. I can't decide. Your love is sending me round, thinking out loud. Baby, come, let's get down. I can't decide whether we should try and make it work. Far too much wine. I know that we should take the day off work. Ooh, baby, let's groove it out. I wanna see you smooth this out. Let's take it round and keep it moving all night. Ooh, baby, just take it down. I wanna see you spin around. Let's take it down one more time, 'cause baby, I can't decide. Your love is around, thinking out loud. Baby, come, let's get down. I can't decide. Your love is sending me round, thinking out loud.
Hello, are you back? Okay. Okay, so we're going to come back to the next startup, okay, which is, so we're going to have Kai presenting Pegasus. João, you can let him in. Hi, Kai.
Hello.
Welcome. Hi, welcome. So we are here in the pitch room with EDP, and we're ready to hear your pitch. So you can go ahead and share your screen, and you will have 4 minutes to pitch. Okay?
Terrific. Let me go ahead and get that shared here. Okay, are you able to see it?
Yeah.
All right, here we go. Hi, everyone. My name is Kai. I'm the CEO and founder of Pegasus. At Pegasus, we are accelerating the adoption of solar energy through innovative mounting hardware and installation optimization SaaS tools. In other words, we're both a manufacturer of hardware as well as a developer of software. Our pedigree is we've installed over 200,000 of our systems in residential applications across the United States, and we're now expanding into utility scale solar. In terms of EDP, we focused on two of your focus areas, installation and O&M of distributed generation and distributed generation for B2B clients, for example, behind the meter systems. The problem today is as module prices decline, the shift of focus for development cost reduction moves to land, labor, racking, and BOS. Back in the early 2010s, when module prices were expensive, you needed a dual axis tracker, 2 mechanical contraptions to maximize energy production. As module prices declined, that shifted to single axis trackers. You could reduce one of those mechanical contraptions and still have enough power generation to make the economics work out. As module prices continue to decline, the economics of trackers erode in favor of simpler mounting solutions. The second problem is that low-cost flat land is becoming less available, which requires either expensive terrain-following trackers or costly land grading and other civil works to make a suitable site. Our solution is called the Pegasus Scale System. This is an east-west high-density system, 0.6 hectares per megawatt, which means you have lower land and O&M costs. Here's an example of a system we've modeled, 257 acres for a single-axis tracker, whereas the scale system is 44% less land to make the same power generation. There's also only 5 components and no moving parts, which means it's faster to install and also lower O&M. It's terrain following up to 40% grade in 2 different dimensions, so you don't have to grade the land or do costly civil work. And it supports the next gen 720 watt modules, those huge utility scale modules, lowering your dollar per watt cost, and also only has 1.5 meter deep piles, micro piles, which reduces the subsurface risk obstruction, for example, rocks. The pilot we're looking to do with EDP is half to maybe 2 megawatt pilot installation developed by EDP, ideally one in the EU, one in Brazil to understand the different geographies and skill sets by the local workers. And we have two objective timelines. Near term, demonstrate the product with lower costs, undulating terrain, trial manual and automated installation of piles using a compact pile driver, which reduces the cost and equipment necessary. Demonstrate the installation speed of modules and wiring, given there's just a limited number of components, and test our layout software. Long term, we want to validate the O&M costs with vegetation management and module replacement, as well as measure the generation output of an east-west system. What you see here in the top right is an image of our first very small scale pilot we did here in California, which you're continuing to prototype right now. Thank you.
Thank you, Kai. Thank you for respecting the timing. Okay, so now let's go for Q&A. Who here has questions?
Okay, I have a question. Hi, Kai. One question. You were displaying some pictures on your panels in the ground. How about the rooftop? Do you have something to show, some examples where we can imagine this for a rooftop? Is this applicable?
This particular system is purely meant for ground applications. Our company does have rooftop applications, which I'm happy to go into, but it's not necessarily the scope of what we're looking to pilot here.
Okay, so basically you want to focus the pilot on the ground, yeah.
Yes.
And are you looking more at DER or utility scale? What's your target in terms of deployments, in terms of scale of deployments? Is it dozens of megawatts? Is it 1 or 2 megawatt small installations?
Well, the nice thing about it is it scales to both size projects, similar to how modules work in residential all the way up to utility, even though their form factor is slightly different. Our target is initially in small scale installations because it is very simple and allows us to work through the installation steps, but it really has the opportunity to go into multi 100 megawatt size projects, like I showed in this other image of the layout.
How much more energy can you squeeze out of a square meter than to a standard installation?
So in terms of megawatt capacity, a tracker system uses 4 times the amount of land for capacity. It does have obviously higher generation of tracker per capacity, the capacity factor. So it produces, in this scenario, it can produce up to, we calculated about 80% more megawatt hours per acre or per hectare.
80 or 18?
80. So here's an example image. On the left-hand side, 257 acre system. This is in the US, so apologize for the units here. 91.5 gigawatt hours per year. 257 acres, same size, 165 gigawatt hours per year, 80.5 more production, same land. This is a job site in Virginia.
And what you are selling, it's the layout and the actual structure for the installation, or just the layout?
Yes. No, we manufacture the structures and we also have software that does all the layout.
Okay, and is it feasible in Europe or it just work in the US?
No, it's definitely feasible in Europe. We are designing to be a global application, which is one of our requests to do a pilot in the EU and potentially Brazil as well.
So if we share with you a specific plot of land that has inclination, you would be able to forecast what additional amount of energy does your system produces against stone.
Correct.
Okay.
Yeah. We developed these 2 layouts you're seeing on the screen here. Our software did this, and then we'd also manufacture the componentry.
Okay.
So a quick question. I don't know if you presented any cost reduction associated. So you were talking about the simplicity of the solution of installing the solution to bring down the cost of installing. I don't know if you shared what was the expected drop in cost of that. And the other point that I would try to understand, how does that compare to it seems to me and that the higher density of solar panels will also can have a cost saving in installing, and you have more land available, you're more effective per acre. But then how does that translate to OEM costs?
Yeah. So this is a slide that has a bit more detail on it. and I'll try to explain it just for the sake of time and briefly. What we're looking at here is the total project cost in thousands of dollars. A 1 megawatt single axis tracker system, the amount of megawatt hours per year, so the same generation at a 30-degree latitude. Single axis tracker, as the module costs go down in price, as the orange band, the project costs go down, of course. To make the same amount of production, a south fixed tilt bifacial system is the light green. It's a little bit higher. It's almost higher in most cases. That's why that there's a band they're overlapping. Our system, the scale product, if module costs are really high, it doesn't necessarily make sense. You know, if module costs go really high, it's go back to dual axis trackers. We don't see that happening. As module costs go down, it becomes economic in almost all cases. So we are expecting our product dollars per watt ASP to be in the 4 cent per watt range from a cost standpoint. That's just going to be your CapEx. Obviously, there's the land savings and civil work savings in the development, as well as installation savings.
Thank you. Thank you, Kai, for your presentation and for answering our questions. We ran out of time. Actually, we went through it, but yeah, so thank you. We'll let you know the results in the next few weeks, okay?
Terrific. Thank you very much. I appreciate everyone's time.
Thank you. Bye. Okay, so next we have Adrian from New Sun Roads.
Should be entering now. I'm getting that.
Hi, Adrian.
Hello.
Hi, welcome. We are here in the room with EDP, and we are ready to hear your pitch. So yeah, you can go ahead and start presenting. You have 4 minutes.
Great, thank you. Okay, well, hello, I'm Adrienne Pierce. I'm the CEO of New Sun Road. We are a public benefit corporation based in Northern California on a mission to accelerate the deployment of renewable energy resources. We work on impact projects, partner with utilities, and serve industrial and commercial clients. With the mandate for a cleaner future, there is electrification that is driving EV growth, which is increasing the need for chargers. Charging stations will grow by 8.8% through 2030. Where is all of this power going to come from? Many places of the grid are at capacity or oversubscribed, and there is often a lack of infrastructure where there's a lack of transmission lines on some of our transportation corridors. How are we going to support EV fast charging to support the electrification of mobility? This is where New Sun Road's Stellar platform comes in. We can help to address the need for capacity and removing constraints for fast charging through our Stellar platform. It starts with an edge controller that connects to DERs such as solar, batteries, and generators, communicates with the grid, and imports other types of information from sensors and breakers. All of that information and control is sent up to our cloud-based platform, which allows you to control fleets of systems from one dashboard. We offer load management and energy optimization. We are proposing a pilot project with 3 demonstration modules that will enable and remove the constraints for EV fast charging installations. The first is DER power management. The second is performance optimization. And the third is showing power management algorithms for demand and response and time of use. The first, for DER power management, we will be looking at solar and storage, grid tied and off grid, and introducing EV fast charging. We'll be looking at what are the best conditions, the trade-offs, and how the solution offers different ranges and what are the cost estimates. The second is performance optimization, adjusting for seasonality and daily considerations. demonstrating power and energy management, ensuring reliable charging and minimizing customer frustration. And the third is comparing cost benefits of dynamic versus static set points. And the final module is power management algorithms based on forecasting, looking at vehicle throughput, charge curves, and aggregating consumption, not only for EVs, but considering bidirectional charging and other loads, such as a building load for HVAC. We'll add vehicle to grid charging, in consideration of the state of charge of the battery and how the usage is affected by bidirectional charging. The New Sunroad team is a group of seasoned professionals. New Sunroad has been around for 10 years, and we have a flexible, innovative technology that integrates with any smart equipment. We have a foundation of experience where we have 1,500 DER systems under management, and we're already partnering with utilities here in North America, such as PG&E and Southern California Edison. So to address the capacity for fast charging, we'll be demonstrating DER management, how you can extend a fast charging network quickly and cost effectively, how you can manage loads and provide cleaner power to manage customers' needs. Thank you for your time, and we look forward to working with you.
Thank you so much, Adrian. So now let's go for the Q&A. Who wants to start?
I can go first. Thank you, Adrian, for your presentation. Just one quick question. Like in all the projects that you've done or in the project, how much optimization have you been able to achieve on the peak? So like, have you been able to reduce the peaks using these kind of smart batteries or so? Can you give me like a percentage or a range of percentages on that?
It was hard for me to understand the question. You broke up a little bit.
Sorry. So I was saying that, okay, I mean, you have these distributed loads and you have certain assets in place. And let's assume that you have a building which is sort of using your technology, right? So how much optimization are you able to achieve using your asset? And you can maybe answer that in the way that how much peak shaving were you able to achieve, let's say, to improve on the grid.
Yeah, so we have done. So you're talking about peak shaving or demand response and how much you can save. A lot of it depends on the size of the project and the situation. We did a project to reduce generator usage in some off-grid sites, and we're able to show that we could reduce it by 10 to 20% by optimizing the battery storage and making sure that the generator was going to only be run. We're looking at bringing in weather and forecast information and load prediction data so that the generator was optimized to run only to cover that shortfall, taking into account whether the load was high or low and the seasonality of it. So those same principles can also be applied to load shifting. They can be applied to demand response. We've done some work showing that as well on the demand response side, taking in a signal from a DERMS and showing that we can operate the DERs so that they can continue to deliver reliably on the load while responding to the need of the utility and reduce some of the requirements for those DERs from the feeder line.
Okay. And how many assets in one area can you be connected at simultaneously? So like EVs or other source?
Yeah, we don't have a limit. If you think of it more of as a hierarchy where you're looking at clusters of DERs and then building that up and operating an area and then optimizing that area. So we tend to operate in sort of remote systems, and we're looking at what we're really good at is doing lots of small systems, so less than 500 megawatts, and then aggregating those to operate in concert with each other.
Right. Okay. And sorry, just the last question maybe from my side. What's the granularity that you work in? As in, how in what Is it 1 minute, 5 minute, or 15-minute granularity?
Definitely 1 minute granularity, but because we have the controller on site, we can do, down to, for the control aspect, it can be down to, several seconds.
Right. Okay. Thank you.
There's time for one last question. Okay, so that's it. Thank you, Adrian, for your time. Thank you for being
Bye-bye.
here today. We'll let you know the results in the next weeks. Okay.
Okay. Thank you. Bye.
Thank you. Bye. Okay, next we're gonna have David from Voltfang. Join. Hi, David. Welcome.
Hey, everyone.
Hi. So we are here in the room with EDP and we are ready to hear your pitch. You can go ahead, share your screen, and you have 4 minutes to pitch.
Perfect. Okay, do you see my screen?
Yes.
Perfect. So, hey everyone, my name is David. I'm one of the co-founders and the CEO of Voltfang, and I'm introduce you to Voltfang today. Everything that can be electrified will be electrified. That's something Andrew Horowitz said. But what if we fail to create the necessary conditions for sufficient grid and environment for renewable energies to fuel this hunger for electricity? If we fail, we will have to continue relying on fossil fuels and coal plants, which need to be mined, transported over several thousand kilometers, and burned with an efficiency of less than 30%. We have the knowledge to prevent this from happening. So Voltfang has a two-step plan. What we need to do is to decentralize the grid. And what I mean by that is really, for example, in Portugal, we need to expand the grid to make it easier to distribute renewable energies from A to B. But this is going to be hard and it costs a lot. So what our part is to integrate battery storage systems and make regions extremely self-sufficient and also integrate them to the grid to really, if a lot of solar energy is produced, to really gain from them, fuel the batteries, and then give it away when it's needed. For example, just recently, the Portugal government said they want to start with granting 100 million to energy storage system projects for example, 500 megawatts. So what does this plan look like? What we firstly need to do is to build sustainable battery storage systems at scale. And at Voltfang, what we are doing is we are using high premium car batteries after their first life, or also from overproduction, so second life batteries or second use batteries. We purchase them directly from the big OEMs in Germany and Europe. And then after testing that with our own developed battery storage testing facility, we can qualify them into our battery storage system and integrate them. The amazing part of our innovation is that we have different kind of products, from small size for supermarkets, bigger ones for logistics centers, but also we have container batteries for grid scale applications. And the beauty of it is that we are always using the same platform for each and every battery. So we can just stack them up and we reach the desired capacity for a logistic company or for a grid storage system, which can be co-located next to a huge PV farm or wind farm. And that being said, our storage system has a really huge flexibility because we are just using one platform for several customers. We are always using the standardized components through our products, and which gives us the economy of scale and less complexity. We developed our battery storage system with the ambition to install them within 2 hours, which where we also gained a lot of knowledge over our past 4 years, where we installed over 200 systems. And due to the reason that we are flexible on our battery module side, we can integrate different kind of module batches at low price extremely fast into our storage systems. This approach already a lot of blue chip customers using. For example, Aldi, Goldbach, Strabag, Vonovia, all of them have a Voltfang storage system already there running at their locations. As mentioned, we have already produced over 200 systems which are running. The second step of our plan is to make this battery storage system with our energy management system as smart as possible. Our idea is that the battery, which is a piece of hardware, needs to be connected to charging, to PV, to the grid, to be as efficient as possible. Therefore, we develop also our energy management system on being as flexible on different kind of use cases. So we have different kind of flexible capacities which can be used for different kind of use cases. For example, if we know we have a peak, then our battery storage systems can shape this peak, or if we know that a lot of solar energy is produced, we can store them in our facility. And due to the reason that it's optimized, we can even use more capacity than the battery storage system actually has. Looking at the possible of a pilot project, we are looking at batteries which are co-located to solar, or also just standalone battery storage system which are integrated at the energy market. For example, here we have a substation on the left side. On the right side, we have 3,000 square meters. It's in Germany, but similar projects could be possible in Portugal as well, where we connect our battery to the substation and are able to really trade the battery capacity on the market. For example, here in Germany, we have a 10 megawatt, 20 megawatt hour storage system, which is running at Q2 2025. And due to the volatility, we see a huge IRR possibility there, which we also see in Portugal, for example. This would be some kind of pilot project. It doesn't need to be 20 megawatt, but it can be around 3 megawatt hour to 20 megawatt hour, depending a little bit of the pain points of EDP currently, which we could then try to deploy within really short amount of time. This is just possible because we have a extremely stellar team with a lot of people who gained a lot of experience from big corporations and are making this vision of enabling a future worth living together happen. Thank you very much.
Okay, thank you, David, for your presentation. Let's go for Q&A.
Let's go.
I think Giselle was unmuting her, so I don't know. Do you want to go first, or? Well, if not, I can go first. Well, my question is regarding the costs of your system. So
yes.
How does that compare with traditional batteries?
So since we are using a really high premium batteries, but we are focusing on second use batteries, for example, nearly new batteries who have been just stored, but we can buy them in big batches. We are extremely competitive to all of the prices all over Europe, even to the prices of the Chinese ones. But what we provide is really also the production within Europe, the monitoring, the service, everything around it, which is incredibly important because if you are trading on the grid, you are not able to have no uptime. You need to have the uptime, otherwise you get penalties or you destabilize the grid. Therefore, this is not always the whole package. We can also integrate different kind of traders inside. And this is all like energy management system with battery storage system is extremely competitive to, for example, competition. So we are talking about 250 to 300 euros per kilowatt hour.
Okay. What's the round trip efficiency of your batteries?
Sorry, what?
Efficiency.
We are at 93% for charging and discharging. Okay. And the round hours is around 86.
Okay. And then regarding manufacturing,
yeah.
Well, two questions. One, how long does it take to manufacture from the moment that you have the purchase order? And what's your current manufacturing capacity in megawatt, let's say?
So our current capacity is roughly 100 megawatt per year. This year, next year, we are in a new facility where we have more space. We are roughly at 500 megawatt, which we can produce. It's just a matter of space. We could also deploy production in Portugal, for example, extremely easy because our production is extremely lean and we have good cooperation partners who can deliver us the pieces we need.
Okay, but then regarding your costs, you say 200 to 300. Is that current, or it's your planned
current?
And you plan to decrease that at some point, or it will stay like that?
We will try to decrease that all the time. So
Okay.
it's a little bit depending on the battery prices and also on the volumes, but we are also planning to decrease that.
Okay. And then regarding state of health, just to finish, state of health and degradation, what's your expectation?
We have our own developed testing facility which really can detect the state of health. What we see right now at the most of the batteries, we have over 100%, so 104% of state of health currently, and we believe that they will hold at least 15 years, more likely over 20.
Okay, clear. Thank you.
No worries.
So thank you so much, David, for your presentation and for answering the questions.
Of course.
We'll let you know the result in the next weeks.
Perfect. Thank you very much for your time. Have a great day.
Bye. Okay, so hi. Next we have Jan and Steph from MyGrid. Welcome, both.
Thank you.
Hi.
Hello.
We are here in the room with DDP and ready to hear your pitch. So you have 4 minutes. Go ahead.
Hello, my name is Jan Wellens. I'm the founder and CEO of MyGrid, and with MyGrid, we are unlocking the future of energy one plug at a time. The MyGrid story actually started 12 years ago, where I built my first battery pack for a solar car, which we then raced through the Australian desert, competing with a lot of other international teams. Now, I was really bitten, let's say, by renewable energy, and I live now in a small apartment in Brussels. I was thinking, okay, how can I also partake? And energy storage, of course, is one of the easiest way. But when I asked my girlfriend if I could install a Tesla wall in our living room, she was not really happy with that. And actually, I'm not the only one faced with this problem. 46.2% of the European population is also in the same problem. So meaning if you want to do an installation of an energy storage, you have to have permission of your landlord if you're a renter, or ask permission of all your co-owners. Then once you have this permission, somebody has to come by, they have to make a quote, they have to come back, they have to do the installation, and then somebody else has to come back and do the recertification of the installation. So a lot of hassle. This is why we came up with the Model 1. The Model 1 is a plug-and-play home battery, which you can just plug into a normal power socket, and this then allows you to take energy from the grid, but also give it back through the same power socket. We also made it so it could fit in any living room, and this has been internationally awarded with multiple design awards. The Model 1 has a capacity of 1.5 kilowatts an hour, which roughly equals 1/3 of a small family daily energy usage, or 125 times charging your smartphone, 25 times charging your laptop, or 3 times running a washing machine. The Model 1 is part of an ecosystem, so there's also a mobile application, which is also bridged with a cloud platform, which makes the links to the existing infrastructure of the clients, but also makes the links to new grid data and grid services available. The goal of MyGrid is really to make the energy transition accessible to everyone, and not only people currently already having solar on their roofs, allowing them to charge energy when it's cheap and discharging it when it's expensive. Now, how do we want to do that? Well, many individuals can be grouped in a community, and this community can then be used and leveraged to also offer these grid services to the grid. You may say, well, this is a very good idea, but can you also prove it? Well, luckily, we just finalized actually already a pilot where we did that, where we were in a community of 500 participants, and we added our Model 1 system in this community, allowing people on one side to lower their energy bill, but also prevent grid congestion, which was one of the issues of Alliander in Amsterdam. So now, who are we? We are a team of experts. On one side, myself, I'm an electrical engineer and also a product designer. We then have Steph, who is also in the room here, who has run a company before, and he's head of our commercialization. And then we have two very strong a digital marketeer, Jan van den Eekhout van den Ende, and then Joris Dupont, who is an IoT and software engineer, to really bring a good mix of skills to solve this ecosystem problem. And I don't see my time, but I think that should be around 4 minutes.
Yeah, it's over. Thank you for the presentation, Jan. So now we can go to the Q&A. Yeah. Who wants to start?
I can start, Jan. Thank you for the presentation. What is your business model? What is the business model that you envision for this product, considering not only your role as the equipment supplier plus some sort of, I don't know, revenue sharing or based on the gains that the customer gets, but also what could be the role for EDP in your business model?
Well, I think like we stated, it's an ecosystem problem. And one of the challenges we are faced now is how can everything be matched together. So what we also figured out in this previous pilot is what remuneration can be given to the clients and what problems can be solved for EDP in this case. And it's really a combination of knowing what the problem is before you can solve it. And indeed, the business model is a combination of hardware sales, software subscriptions, and then these extra grid services, which there can be a split between profits between the customers and MyGrid.
Okay. What's the hardware cost?
So we're now selling it for 1,750 euros, including TVA, and we have done a successful Kickstarter where we sold 150 units last year. So we really know people want the product, and we also learned a lot of the feedback they already gave.
Okay. Last question of mine. If we were to prove this technology, to pilot it somehow, what's your ideal pilot? So how many participants to do exactly what? And I can imagine it will depend on the problem that we want to solve. But ideally on your end, what would be the setup?
Ideally, it's around 100 to 500 participants, potentially to scale it a little bit. And there should really be an impact if they are in a community visible to solve a real issue for the energy market players like the DSOs or the energy suppliers, showing that leveraging the capacity is beneficial for everyone actually, and also creates more commitment from the users than you will have with these bigger energy storages.
Okay, clear. Well, I have one other question actually. When you aggregate, so for the communities, when you aggregate these small batteries, for EDP, do we see it as one battery, and then we can provide set points if we want to participate in the market, or do we have to manage each individual battery?
No, indeed, it can be seen as one asset, which then can be guided in the direction wanted based on set points. But it will probably be multiple communities existing as assets in the cloud.
Okay. There's a question in the chat from Hugo saying, what is the input and output power?
800 watts. So we can charge 800 watts and discharge 800 watts. Charging can be up to 1,500, but for discharging, we're limited to the existing cabling.
Very good. Thank you.
Okay, so thank you very much, Jan and Steph. Thank you for your presentation, and I'll let you know the results in the next few weeks, okay?
All right, super. Thank you, Margarita. Bye.
Thank
Bye,
you.
everyone. Thanks. Bye.
Okay, so we have one started before the next break. So we're gonna have Dimitri from Enreport. Hi, Dimitri.
Hi. How you doing?
Hi, welcome.
Thanks.
Okay, so we are here in the room with EDP, and we are ready to hear your pitch. You can go ahead and share your screen, and you have 4 minutes to pitch.
Okay. Can you see my screen?
Yeah, we can.
Okay, let's do it. So, hi guys, my name is Dmitry, and I do energy management software, and I'm addressing my solution to electrification of industrial heat and air. So to make it easier, I will bring some context. Let's imagine I am a global energy efficiency manager in a steelmaking company, okay? So as a global energy efficiency manager, I have to manage energy consumption and energy generation in different plants across the world. Let's say in Brazil, the United States, Portugal, and Spain. So, and I can do it by using Enreport. Just drag icon from the list and drop to the field and create as many properties as I want. And then I can dive deeper in a plant and recreate my energy consumption process virtually. So I can bring electric arc furnace in the field, then solar panel or boiler or air compressor, everything I want. And thus I can recreate my energy consumption process. By using digital twins, we mean that Enreport is combining physical-based equations, real customer data from every piece of equipment, and performance map that provided by equipment vendors. So, and we bring it together and run our neural network. So Enreport basically utilizes physics-informed neural network technology. And then I can set up my all energy contracts, electricity contract, natural gas contract, water supply, everything I have in a plant. And then I can get all market information about electricity trading, natural gas trading. Also, I can easily connect all my real assets to digital twin by creating virtual meters using IoT devices, sensors, and all we have. Then I will get a real-time recommendation on how to run my equipment to face the future energy demand and to proceed with my production plan. And then neural network will detect, let's say, will detect anomaly in working mode of air compressors or boilers or electric motors. And more than that, Enreport will will track energy intensity for each batch of product, benchmark real assets, and And me, as a global energy efficiency manager, need to decarbonize my production process. So I would like to calculate different options of new type of equipment. Like what can I install in the different plants? Like if I can do heat pumps or heat storage or like boilers or thermal storage, whatever. So, and Enreport can help me with that. For everything, for every single plant, Enreport will calculate different options of different equipment types. And I will get hundreds of calculations. So I can go deeper in each option and get return of investment rate, profit generation data, radiance data, and I can just push order button and Enreport will connect me with the equipment vendor. And then after installation of new equipment, I will get new recommendation in Enreport how to run my purchased equipment. So, and and my proposal to EDP is to test Enreport as a white label solution for industrial customers to select new type of equipment like heat pumps, thermal storage, boilers, and others. So we have done our project with steelmaking companies, paper mill companies, chemical companies. Now, that is the team behind Enreport. We have been working together for 10 years and have a great experience in industrial energy management software. So that is all I have for you. Please do your questions.
Thank you, Dimitri. Let's go for Q&A. Who has questions for Dimitri?
I can ask some questions. What kind of effort is it needed for you to create digital twin? So, and what kind of equipment really works with this? I mean, would you need to install sensors? Does this only work with specific types of equipment that can be integrated? And what's the effort associated with going to a plant, gathering the design of the plant, all the equipment, and then mapping it into the platform?
So we have been working with heat pumps, boilers, steam turbines, gas turbines, electric arc furnaces, ladle furnaces, stones, so containing casting machines. We need to collect historical data from our clients. We do not install sensors. We use existing measurement system in our client side. So also we collect production plan and collect schemes. So, and for building digital twins, we need model of equipment, performance curves or performance map from manufacturer, and real data. Did I answer?
Yes, but so from a business perspective, are you offering a platform that you license as a service, or are you offering the consulting services, the people that go there and do that work that you just described?
Just we offer license. Like usually utilities companies go to us and say, okay, we would like to have your platform in our website, like a white label solution that, let's say, customer in Brazil can go to our website, sign up, and get all information. So, but it takes a few consultancy moments to deploy the system and help customers to do it, to recreate energy consumption process virtually. I can provide an example. Like we work with Panasonic. They provide us a lot of performance curves, of different models of Panasonic heat pump. And let's say Lidl or Tesco come to us and say, okay, guys, we have hundreds and thousands of grocery stores, and we really need to calculate for all of grocery stores which type of heat pump we need to install. And then please, guys, help us to manage like thousands of heat pumps. And usually we request this. Yes, of course, let's do that.
I think we're running out of time, but I have one very last question, which is, can you clarify, can you put back the slide on the pilot project? Can you clarify exactly what do you do as part of this pilot project? Is it about integrating a set of assets and provide all these digital twin? How exactly you would run this pilot?
Okay. Let's say like EDP has an industrial customer, and I'm imagining. So let's say EDP has industrial customers and has a good relationship with the industrial customer, and then what we do, we will request like data, equipment models, and production schemes. Then we will recreate it, and for this industrial customer, we will calculate different types of heat pumps, thermal storage, and boilers, and like calculate thousands of options and show industrial customers the best options for them. So.
Okay, clear.
Okay, so thank you so much, Dimitri, for your presentation and for answering our questions. We'll let you know the results in the next weeks, okay?
Okay, choose me. Bye.
Bye, thank you.
Thank you.
Okay, so now let's go for a quick break and let's be back in 7 minutes, okay? Okay, 7 minutes.
Things have been difficult, it's true. Go eye to eye. Maybe we can dance this thing through. Ooh, baby, let's groove it out. I wanna see you smooth this out. Let's take it round and keep it moving all night. Ooh, baby, just take it down. I wanna see you spin around. Let's take it down one more time, cause baby, I can't decide. Your love is sending me round, thinking out loud. Baby, come, let's get down, let's get down.
Hello, everyone. Are you there? Okay. So now we're going to go to the last 5 startups of today. And I'm going to call Gordon from Andrual AI. João, you can let him in. Hi, Gordon.
Hello.
Welcome. Hi. We are here with EDP. So you're in the pitch room and we're ready to hear your pitch. So yeah, we can see your screen and go ahead and present. You have 4 minutes to pitch.
Perfect. Just give me 1 second. All right, you can see my screen?
Yeah, we can.
Perfect. All right. Lovely meeting you. I'm Gordon, founder of Andrual AI. We're building a co-trader for renewable energy companies. And in our research, we found that, at least in Germany, there's enough energy being wasted to power 2.1 million homes for an entire year. And that's because there's simply not enough storage, there's terrible distribution, and all of this is underlined by lacking market insights. So the way we want to solve this is by supplying the energy trading market with Andrual AI, which will be able to create twice the returns, allow traders to make faster decisions, and completely have a complete data accessibility and understanding. Now, in detail, what this is simply a smart trading management assistant. You can visualize the entirety of your data. You can analyze it through a LLM window. You can create historical backtest simulations to de-risk your trades and execute these trades in 1 click through our smart templates. Now, on the side of our business model, we decided to go with a commission-based business model that is based on 0.8% of every megawatt that is traded through Andrual, which means by circa 2030, we can reach 106 million in revenue by charging about an average fee of €1. Now, we've already made promising progress. We've signed 2, actually 3 LOAs at this point, which would total 50 users, not 30 anymore. But apart from that, the partners we work with are leading trading companies in Germany who trade excess of multiple megawatts, terawatts even, across the year in the EPX spot markets. Just finally, to the team, the man behind the technical magic is Saurabh Raj. He's my co-founder. He's worked with energy traders for 10 years. He's built trading algorithms with them and is an expert in AI and machine learning. And his previous company was sold for 4 million to Convex Energy. I myself, I'm absolutely on the commercial side. Anything sales falls and operations falls into my quarters. I've generated circa 9 to 10 million in revenue for the previous companies I worked for, and scaled a prop tech startup, which was then sold to ImmoScout. And that's about it. Thank you for listening.
Great, thank you. Okay, so now let's go for Q&A.
Yes.
Hi, Gordon. I can kick off with some questions and thank you for the presentation. Probably the first thing is, how is this different from the let's call it traditional system that our trading desk may have? So how does that differ? That's one thing. Mm-hmm. And the other is, let's say that there's value in the system. Typically, mm-hmm. your customers move their own system to this one, or there is some sort of integration between the 2 systems and you end up using both or controlling one with your own. How does that work?
All right, and it's a bit of a 2-part question. Let's start with the first one. Now, how's it different to what is being used nowadays? obviously this deck is shortened and all the processes behind it are massively shortened. But in general, when a trader executes trades, he tends to spend 30 seconds in a CSV file, which is packed with data points from A to Z. And they kind of work with a bit of intuition. They've done it for a while as well, so they kind of know what to look for, but they oftentimes miss nuances in these data points. And with our tool is more of an add-on initially, where they can actually speak with the data that is in front of them. They can spend less time on the analysis and still have better results. Now, in the short term, it can only be an addition. It's nearly impossible to move a trading company away from their current tech stack. They absolutely love their servers, they love their cloud solutions, they love their trade execution, and whatever else they've built probably in-house. However, if there's something that can actually improve their P&L, even just give an extra euro on every profit profit made, that is already a massive upside. Now, what we're saying is, today, traders, in order to de-risk trades and create backtests, for a larger trade execution, this is a process of a week, maybe 2 weeks, depending on the size of the technical team. However, with this tool, they can do all of this essentially whenever they want. They can choose between the backtest they want to execute. They can see how they want to de-risk their trading strategy. And so initially it's an add-on, but we know that traders sit in front of 6 to 12 screens on a daily basis, and they obviously miss a lot of details. The traders we speak with, they use an Alexa device to remind themselves to look at screen 1, 3, 5, and so on and so forth, just so they don't miss anything. And this tool is supposed to replace situations such as those where they can come back to it and know all the details are there.
Okay. One very last question on my end. How does pilot look like? So how could we test your platform? Is it to run it in parallel with our own systems and then compare results and see if there is a gain? Or how would you suggest us to test the platform?
In my solution, what I presented, there were 4 parts of it, right? And one was visualization, the other one was live interaction. So speaking with the data through an LLM. But this part we can deliver immediately. And what this already proves is that a trader, if he wants deeper analysis, doesn't need to go to his data analytics team and wait for 3 to 12 days for the analysis. They can just type in the question: how does the day-ahead price correlate with the wind energy production in North Germany? It's a very specific question, but that's just one of many questions traders ask. And they can go crazy on this side because we're connected to their data set, to their database, and we are therefore able to simply give them the answer based on whatever is in the database.
Oh, clear. Thank you.
Okay, we run out of time, so thank you so much, Gordon, for being here today, and we'll let you know the results in the next weeks.
Right. Thank you so much.
Thank you.
I just leave the room.
I just removed him. Okay, so now we're gonna have Kari and Samir from Molecule. As well, you can let them in. Hi, Kari. Hi, Samir. Welcome.
Thank you.
Hi. So we are here with EVP and we are ready to hear your pitch. So go ahead, share your screen, and you have 4 minutes. Yeah, we can see it. You're muted, Samir.
Hi.
Yeah. Okay, now it works.
Hi, everybody. I'm Samir. I am the founder and head of Molecule. Carrie Foster is here as well. She's our head of marketing. We're glad to tell you a bit about our company today. So Molecule is the world's most modern ETRM. If you're not familiar with ETRM or CTRM acronyms, basically they're like ERP systems for any company that touches energy and commodities at any scale. Basically, it's a system of record for each transaction and forecast and its position, so quantity, its valuation or P&L, and its risk. So if you're trading, how much might I lose if tomorrow is a bad day, but not a catastrophic day? What's a normal loss? The industry's been around for 40 years, and Molecule is one of the new entrants. And you can see us on the top right here moving towards market leadership. So the thing is, these systems were built, a lot of them for crude and gas, which are things that move monthly or daily. In the US, for example, power moves hourly or every 15 minutes or even every 1 minute. And so it would take a new system to handle electricity well. Renewables, especially in the form of certificates and credits, change shape all the time. Well, Molecule is the world's most modern multi-tenant platform, which means we release updates every 2 weeks. And because of the sheer horsepower of the cloud offering that we have, we can handle things that are very, very difficult, like multi-decade long hourly settled power purchase agreements, and get you a sense of what your position is even 20 years out. Also, we have the best API in the ETRM industry. Most of our legacy competitors do not, and this is one of our customers' favorite things about the system, is that you can get everyday data in and out. And everyday data is quite a lot. It could be 200,000 rows, 200 columns wide of valuation data in and out every day. What we propose to work with EDP on is our new Hive offering, which is a feature that allows you to automatically allocate renewable certificates against obligations, either voluntary or regulatory obligations, and optimize the use of those certificates on a screen and using an algorithm that we custom develop with you. So we're using this here in the States. And this screen was developed for really certificates and all sorts of carbon sources. We think it'd be something really cool for EDP to use, for EDP to use, because we use similar things with our customers, EDF, SoftBank, Energy, and M&A. So we do the hard things. And we are very proud to do some of the hardest things in the industry. And we think would be great for EDP as well.
Thank you, Samir. Thank you for the presentation. So now let's go for Q&A.
Well, I can kick off. Samir, thank you for the presentation. I thought that I was understanding your solution, but I got slightly confused at the end. Is this more for trading power, or is it more for like hourly matching for the energy certificates? Because there are two different things. And well, let's start with that.
Yeah, so it's really all of those things, because an ETRM is usually the system of record, and it's the thing that's going to allow you to assemble positions of different sorts together. And so typically it's showing you your positions from trading, but that's not all that different from showing you forward certificate positions that are made from the trading and the inventory of certificates overlaid over your forward forecast volumes. It's really the same thing being done in a different way.
Okay, but then you do or you don't do market participation itself. So is this to support a trading desk, or is this to execute the trading itself?
It is post and pre-trade. The execution usually happens somewhere else, and we have a feed that takes the transactions that happen and ingests them.
Okay, and then how do you ingest the REX data?
So we connect to registries directly and download transactions as they happen in your account.
In both the case where we can buy certificates, but also our own certificates?
That's right. So what happens is you book a trade in Molecule, a physical trade that represents, say, a cell of certificates over a period of time. We will enter in that into Molecule as a trade, and then we will calculate the forecasted inventories from that over the trade. And then we connect to the registry and download the actual certificates you get and can match them off against the estimated certificates that you had before.
Okay. I see the GEM team has some questions, so go ahead.
Yes, thank you. And thanks for the great pitch. Regarding the part of certificates, guarantees of origin, what sets you apart? I mean, because one of the harder things to do is to connect different sources, multiple clients, PPAs being established with thousands of industrials, different tech requirements. People want solar, wind. So what sets you apart and how can you answer to this complexity?
Yeah, so what sets us apart is that the platform is modern and is updated every 2 weeks, which means we are able to move very quickly. And so the platform then can natively understand things like vintages and eligibilities and multiple eligibilities, et cetera. And if there's something we don't understand, it can be added very quickly. Our customers are sort of at the forefront of the industry, so they're pushing us all the time. So I think that's a big thing. The system is also designed in a modern way and very flexibly, so we can do really weird things like the weird PPA pricing you see. We have a very powerful formula engine that feeds into formula prices, and we simply use that to model odd PPA pricing. And if there's a function that we don't have that is needed to model a formula, we'll just add it to the library. It's not that hard.
Do you guys compete with companies like Granular Energy that do the matching between like PPAs from customers to guarantees of origin?
We have not seen them typically as a company we compete with. We typically compete with Ion Trading, which provides the in-house solutions, or FIS, SunGard, sometimes Provise, and Orchestrate as well.
Okay, very good. Thank you.
Right. We ran out of time, so thank you so much, Samir and Kadi, for being here. And we'll let you know the results in the next weeks. Thanks.
Hey,
Thank
great.
you.
Oh, take care.
Thank you.
Thank you.
Bye.
Okay. Okay, so last 3 startups. So now we're gonna have Serge from Powernaut. Jean, you can let him in. Hi, Serge.
Hello, hello. Good afternoon.
Hi. Welcome. So we are here with EDP, and we are ready to hear your pitch. So you can go ahead, share your screen, and you have 4 minutes to pitch.
Perfect. All right. Are we good to go?
Yeah, you can see it. Yeah.
All right. Hi, I'm Serge. I'm here today to pitch Powernaut, and I'm actually trying to address some of the challenges. Actually, in fact, I'm trying to address 5 of the 6 challenges today. So that's a very bold statement. So let's just go ahead and dig in it. Currently, what we notice is that energy suppliers are paying tons of money to balance their own retail positions, basically their trading positions. In fact, we notice that year on year, balancing costs are rising up to 32% every year even. This is a specific example for one country, Belgium, but we notice exactly the same trends in other countries. So why is this? And it's just the nature of our energy transition. Energy suppliers typically cannot keep their retail portfolio in check. And why is this? We can dig into this by having a look at how portfolio management typically works, right? You have the generation, the big power plants, we have the wholesale market where you can constantly trade, and then we have the demand side. Historically, demand side has never been generating electricity. That's changing massively with PV all over the place. It's never been connected to the supplier either, and it's also never been flexible. Flexible assets like batteries and EVs never existed 20 years ago, but that's changing massively. So what we are doing, our solution, is making the demand side a tradable asset, which changes drastically how a trading desk would typically operate these days. So what do? Same picture as before. We actually create a cloud-native software product that sits between the trading desk, the portfolio management team, and the retail or demand side. Now that's a bit vague. Diving a bit deeper into what we actually do is we aggregate existing energy management systems, and I know there's a few of them in the track at the moment, actually. And we provide the trading team with real-time insights into what the retail team, what the retail side of things is doing. But we also forecast on an aggregate level the baseline of the next few hours. So really short term, we are working short-term markets, the baseline of the retail portfolio. But more importantly, we also forecast the availability of flexibility over the next few hours. And then based on that flexible availability, we allow dispatching your retail customers, whether they be commercial, industrial, or residential. We dispatch them to activate according to your signals, balancing your portfolio in real time, up to a minute upfront. What does this look like? And we're actually live with the product with one of the major suppliers in Belgium. And by the end of this year, we'll be live with about 65% of the supplier market in Belgium. Basically, it shows the trading team the baseline of the next few hours of the connected retail customers, but also how flexible they are and how they can be steered into a certain position, which then in turn optimizes your hedging risks and your internal balancing positions. We suggest running a 3-month pilot, actually, first consisting of finding customers, onboarding customers that are willing to participate. Secondly, onboarding energy management systems. In Belgium, we have 11 integrated. It takes about 2 weeks to integrate them. One of them, of our existing partners, was earlier today in the call, actually. But thirdly, most importantly, we need to integrate with the trading desk. They need to call our APIs, algo trading, or manually with the UI. And most importantly, not unimportant, we need to settle with the end customer. We need to somehow remunerate them for their short-term grid services that they provided to you. We're doing this with me, of course. I'm the technical person in the team, the co-founder. Florentijn, my other co-founder, is the commercial and operational person in the business. And then we have some machine learning and software engineers part of the business as well. And that's what we do. Open to any questions at this point.
Thank you so much, Serge. Thank you for the presentation. So now let's go for Q&A. Let's just start.
One quick question, and thank you for the presentation. It wasn't clear for me if you actually participate in the market through the aggregated system that you can create, or if this works as a support for the trading teams to, based on the available flexibility, to participate in the market.
Yeah, so that's also how we differ, in our opinion, from our competitors. We are not an independent aggregator. We do not participate ourselves in the market. We provide and create the short-term trading software for your retail site and offer that to the supplier. So we basically embrace the supplier side. We give them the technology to make their demand side tradable. We don't trade ourselves. We also don't believe in the long-term, especially on a residential level, viability of an independent aggregator. Typically, the existing customer contract is with the supplier, and that's also the easiest way to go about it. Residential households don't want another contract for like short-term flexibility with some kind of independent aggregator. It doesn't scale. So we create the software, embrace the supplier, sell it to the supplier, basically. That's what we do.
And the type of customers that you're onboarding, are they so residential customers, or is it can be industrial customers or and so on?
Yeah, so we do, it doesn't matter to us. Our software supports it all. We have residentials at the moment. We also have some commercial buildings. At the moment, we do not yet have industrial ones, but it's completely supported. We don't have big batteries and so on because they typically have some kind of other more complex scheme with an independent aggregator. But we have like 200 to 300 kilowatt heat pumps of commercial buildings. We also have 3-4 kilowatt batteries of residential buildings connected to the platform.
Okay, clear. I think my only concern, and I'm not an expert on this topic, but my only concern is whether the Portuguese market is prepared for flexibility due to regulation. I'm not sure how actually we could explore all the potential of your platform. That's my only concern and thing to be addressed. But apart from that, I think it's clear. Thank you.
All right. Yeah, to add on to that, that's why we focus on portfolio optimization, which typically circumvents regulation. We do not typically focus, for example, in the Benelux on TSO flex markets because they are very heavily regulated and we are too dependent on that. So we focus on balancing intraday trading optimizations, basically, which is essentially the same in most European countries and typically not regulated. They are free markets. It's just balancing of your own portfolio.
Very good. Thank you.
Okay, we still have time for one last question. I don't know if someone wants to jump in.
I didn't expect 20 people, actually. That's cool to see.
Yeah. Okay, so I think that's it, Serge. Thanks a lot for your presentation, for your time. We'll let you know the results in the next few weeks, okay?
Yes, perfect. Thanks, everyone. Have a nice evening. Bye-bye.
Thank you. Okay, so last two startups, countdown. So now we're going to have Mohammed from FlexThor. Hi, Mohammed. Hi, welcome.
Hello.
Hello, welcome. So we are here with EDP and we are ready to hear your pitch. So you can go ahead and start pitching. You have 4 minutes.
Okay. Thank you. You can see my screen?
Yeah, we can. Can you put in full screen mode? Yeah, thank you.
Okay, thank you. So, hello everyone. We are FlexThor and we are here to unlock the full monetary potential of battery storage systems through tailored and customized optimization of battery storage systems. No, businesses and industries and commercial sectors, we all know that they spend 15% of their OPEX on utility bills, energy bills. And to save from this, they install the battery storage and PV systems so that they can reduce their energy bills and then they can become more sustainable. But actually, the problem is that they have a very low return on investment that they're facing, these businesses. It is because the conventional utilization of battery storage is very much limited in terms of self-consumption only. And the lower incentives on energy export is actually giving them a very low return. And that's why they are very much frustrated. On the same side, there is a very high underused period for the battery storage system because of weather conditions and climatic situations. So FlexThor optimizes the battery storage systems together with an IoT solution and software as a service solution where we have a smart algorithms and software which does optimization of the battery storage systems with our advanced algorithm where we can take care of the health monitoring, the state of charge estimation, and all the state estimations of the battery, thereby increasing the income from the battery by 160% and decreasing the payback from 12 years to 5 years. And this is much more beneficial for the businesses, for the commercial and industrial sector where they implement battery storage systems. How do we do this actually? So we utilize the batteries of our business clients by, first of all, doing optimization on the battery storage so that they can participate either in the trading market through intraday or some kind of other trading. And then we also perform the net balancing along with the peak shaving and self-consumption. So our algorithm, they try to always predict in advance that which market should we participate and what exactly is the best market where we can do so that we can maximize the return on investment. And our algorithm along with this also tries to take care of the health and state estimation, all state matrices of the battery, such that we try to take care of the battery health and don't just go for the higher return on investment. So we install the solution in such a way that we have our IoT, we plug the IoT to the customer premises, and then we extract all the data from the customer premises. So we have access of the customer battery storage assets. This is step number one. And then our IoT, which is a plug and play, we plant it to the battery storage system to collect the data. And from that data, we do the forecast and optimization such that the best ROI can be achieved. So we say that plug FlexThor IoT in 10 minutes and our SaaS will give you money in 6 weeks. So along with this, we don't just do the ROI maximization, but also we take care of the battery health and we try to give customer the carbon footprint emissions. So we have traction in terms of high 16,000 revenues that we have generated. We have industrial partnerships and we have a pre-seed investment 25,000 euro with 8 international awards. This is some of our use cases in Belgium and in Netherlands where we have the clients are from industry and from commercial sectors. And we have our team, which is me and Abdul from CTO and Amit from CMO. And I just want to show you quickly our demo in terms of yeah. So we can see that we have our dashboard where the industrial client storage systems can be plugged into our system, and that gives an earning per day and per month and per year. And this also gives an overview of battery storage SOC and state of charge along with the CO2 emission that can be saved, which is equivalent to trees and number of cars. So we take care of the customer premises battery storage systems along with other values that we can take care in terms of the battery cycle that participated in the market and the cycles remaining, such that we have an accurate estimation of the health towards the business clients. Thank you very much.
Thank you so much, Mohammed. Thank you. So now let's go for Q&A.
Hi, Mohammed. Couple questions on my end, and thank you for the presentation. So first question, my assumption is that you run both battery analytics and trading in your platform. And I was seeing on the demo that besides the storage system, you also have solar grid. So my question is twofold. One, what type of data besides the IoT that you have on the battery do you ingest? And are you market agnostic? So can you work within Iberian market, for instance, and trade the battery that we provide, let's say?
Yeah. So to answer your question, number one, so along with the battery storage data, our industrial clients or business clients, they also are very much interested to have the knowledge and information on other data, like for example, the solar data and their consumption data. So they want every data on one platform. That's their requirement. So that's why we have a demo. We have shown the demo that all the data are there in one platform. And we are very much focused on the battery. So we are specialized on the battery systems. Number two, yes, we are market agnostic because we are operating in the Benelux region and we have the TSOs and which are connected from the north of the Europe to the south of the Europe. So we actually are not that much region specific, but we can also participate in the through the market of EPEX, through Nord Pool, where we can have an intraday auctions or intraday trading markets and also FCR market. So yes, we adapt very quickly depending upon the market specific rules.
Okay. And then what's the business model? Because you were mentioning industrial customers, But
Yes.
what's the business model when working with a utility? Because it's quite clear if there is an industrial customer that owns a standalone battery or a battery integrated with solar, and you manage the battery for them. But in the case of a utility that can already participate in the market with that battery and so on, what's typically the business model that you have?
So with respect to the utility, so generally the industrial customers or the commercial customers are one of the clients of the utility. So we try to bring in the more specific details on the battery utilization, on the battery available capacity, and also in terms of what can be injected and what can be drawn from the network. So utility has more in-depth knowledge which is somewhat hidden from the low voltage and medium voltage level. So we try to open the gate in terms of information and data towards the utility, which can be taken into account to manage the day ahead scenario and also longer term scenario, that what exactly is going on from the client and the industrial perspective. So the utility gains more open views, and the industrial clients can be managed from the utility through our FlexThor solution.
But then if I understand that the information that we get, but then you would trade the battery or we would do it. And if you do it, is there a revenue sharing with a floor price? How would that work?
Exactly. So there is, of course, a revenue sharing. That means that if let's say we partner up together, and you are going to go into the market to trade, we provide all the trade, like all the battery points, that what exactly is the requirement to charge and discharge on the battery, and what exactly is the consumption. So there will be a revenue sharing model that we really work here in Belgium together with an aggregator, or you can say a BRP. So we do this revenue sharing with them. We also go to trading directly, but where there is a trading directly is infeasible. We go through the kind of a party or a utility which is responsible for the trading. So we have a revenue sharing in terms of 25-75%.
Very good. Thank you.
Okay, thank you so much, Mohammed, for your presence here today. I will let you know the results in the next few weeks.
Okay, thank you. Thank you, everyone. Thank you for listening.
Bye. Okay, so now it's the last startup, almost there. We're going to have Ignacio from EnnoFlow Technologies. So you can let him in. Hello, Ignacio.
Hello.
Welcome.
Good morning. Thank you very much.
So we are here in the room with EDP, and we are ready to hear your pitch. Go ahead. You have 4 minutes.
Okay. Well, thank you very much. My name is Ignacio Juarez. I'm the founder and CEO at EnnoFlow Technologies. We're building an AI-powered demand flexibility energy router. Why we are doing this? Probably you heard this several times during the day, so I'm not going to bother you with this. And our approach to solve and gather these opportunities is mainly trying to merge AI with physical assets management to drive the energy transition. How we're doing this? We have our proprietary Gen AI algorithm, and then we merge that with a proprietary advanced power electronics, allowing us to create real-time dynamic digital twin integrations, AI-driven dispatchable BPPs, autonomous transactive energy platforms, and demand flexibility energy management driven by AI too in real time. How we are achieving that milestone is with 2 key components. The first one is the Compass hardware platform, that it's bridging electrons and data. It's a system that allows us to have seamless DER integration, and it's basically a translator between electrons and data and going back to electrons. It's a self-enclosure unit that includes all the necessary power electronics. That means every safety breakers, ATS, inverters, processors, all together in a single unit, really easy to install, and that can be retrofitted to an existing installation, and allow us to gather data and manage smart but also non-smart devices through the flow of electrons going to those appliances or devices. The second component is our proprietary Gen AI algorithm. We call it Sophia, and it's the brain for demand flexibility. Sophia is allowing us to gather all that information. We're gathering more than 700 different parameters from behind the meter, up to 1,000 times a second. And we use that information to, first of all, do self-learning, but at the same time, learn about the behaviors, the grid stability, DRs, loads, and create and manage the flow of electrons from the behind-the-meter environment. This unit is installed between the meter and the existing panel. We read the flow of electrons, as mentioned, from smart but also non-smart devices. From there, we gather all data parameters. At the same time, we are connecting all the DRs available on site directly to our unit, allowing us to gather and process, but also allowing us to manage those DRs. For example, we include a level 2 two-way EV charger in our unit, allowing us to manage all those different devices. And then we added a layer of AI to our unit. We included Jetson NVIDIA chip processor in each device, allowing us to run the AI platform on site, learning from that behavior, deciding the best flow of electrons, learning from other platforms like weather, tariff, grid status, and communicating with the grid, allowing us to merge the in front and behind the meter environment in a single unit, with the objective to create transactive energy platforms, allowing us to reduce the pressure on transmission and distribution lines and create this last mile energy distribution ecosystem, right? Today we have a worldwide partnership program that includes not only utilities, oil and gas companies, also technology companies like Dell, that is our key and main partner in supply chain and infrastructure. And we are developing different partnerships and deployment of these technologies worldwide. And why we believe that EDP is a great partner for us, of course, we can, and our objective is to be able to run a pilot together where we can deploy this unit. It's extremely easy to deploy, around 15 minutes. You don't need to replace any meter or a smart panel to make the whole system smart. Allow us to seamlessly integrate our AI with any other demand flexibility technology, SAF solutions, and share all this level of information that we're gathering with these third-party SAF solutions that are mainly using cloud-based platforms to optimize the energy. What we are doing is translating electrons to data and then data once back to electrons to really manage what we are doing with each electron, right? So that's our main focus for this project. Thank you.
Thank you so much, Ignacio, and thank you for keeping attention to the time.
Thank you.
Okay, so now let's go for Q&A. Who wants to start?
I'll kick off with some questions, and thank you, Ignacio, for the presentation. So if I understood correctly, you're basically creating a dispatchable virtual power plant where you need to integrate our own assets or our customers' assets, and then you ingest data from the market, I guess, from weather data, tariffs, and so on. So is that it, correct?
Yeah, we created an energy, what we call the energy router. It's a new concept for business here because we're merging a lot of different technologies. This unit is taking control and ownership over all the energy assets from behind the meter environments in compliance with existing regulations. And this unit is allowing us to see and control all the flow of electrons to these different devices, including different breakers. We are reading each electrons to where it's going. So with that information, plus the ability to control those loads by third-party smart switches or just by filtering the electrons specifically going to that appliance or device, we're able to do energy management and decide how we are controlling those assets, keeping demand flexibility really at an autonomous level, right? And then we try to, first of all, reduce the consumption. We are estimating up to 30 to 35% reduction in consumption just by controlling those assets. But at the same time, then we boost generation on all those different technologies connected to us. For example, we have a self-learning Gen AI MPPT algorithm in our unit, allowing us to boost performance on the solar system, for example, that is learning from all those different parameters, temperature of operation, location, amount of panels, the tile of the rooftop, all together to customize the MPPT algorithm, allowing us to boost performance of that array in that specific location, right? The whole system basically is merging all the power electronics needed to do this autonomously plus Gen AI algorithms that we develop by ourselves.
Okay.
And of course,
And then-
that information can be used with BPPs, with transactive energy models, and it's designed to do this P2P energy exchange in the future, right?
Okay. So then 2 questions. One is, for a pilot project, what would be the ideal setup? So the type of assets that you'd integrate, the capacity, so how large these should be to really test the technology. So that's one thing. And the other is, assuming this goes well and we want to scale up, what is your business model as for an utility? Because this can make sense for specific industrial customers where you can manage their loads, but for a utility, it's probably a bit different. So how would that work?
Yeah, first of all, the great thing about this technology and our IP is that the system is completely modular. We're here to manage electrons. That's our business. So the system is modular, and we can scale the units just from residential customers up to industrial. With the same technology, we of course need to change the power electronics. The inverters and breakers in each technology is different, but the whole architecture is the same. We use the same framework, the same software. So electrons communicating with each other is exactly the same thing. That's one of the great things. So we are doing a small pilot project for residential customers up to large industrial projects, for example, in Mexico for a cement company for up to 9 megawatts. So we can do the whole range of solutions and applications here. For us, working with utilities, our ideal customer is to have an environment of at least 5 units installed together in residential customers, allowing us not only to improve performance with different amount of assets that can be non-DRs, just consumption there, and we use our technology to reduce the consumption on that unit. And then different setups, like, for example, some customers with electric vehicles, some customers with solar systems, some customers with two-ways EVs or stationary batteries at different sizes. So we use our AI and technology to be able to create and demonstrate the ability to do this last mile energy distribution environment, doing transactive energy platforms, and show the utility that this technology can scale, reducing basically pressure on transmission distribution line and creating a really AI-driven demand flexibility ecosystem, right? That's our ideal project with utilities. And from there, of course, one of our goals is to create partnerships that we can deploy this technology at a larger scale, reducing the capex, improving the profits and margins, creating better solution, but also providing reliability and stability to the grid too, right? That's one of the goals and concepts that we are actually developing right now in Texas with some customers.
Very good. I know that Gonçalo also has some questions, so we can
Just
go.
one question. On your technology, does the router itself do all the optimization behind the meter? Or can you send all of the information, perhaps aggregating with some other sites, and have a central dispatch for the entire VPP?
I have this on a slide here. We're gathering tons of information, right? And one of the challenges of these companies doing SaaS solutions is the quality of data that they are harvesting. The great thing about controlling the hardware is that we are really seeing the electrons and gathering all that information. We create proprietary information, and we can also read and communicate with all third-party APIs that are working there, like, for example, thermostats or some smart vehicles that have that information. Once we have that, the system and our proprietary Gen AI, Sophia, it's learning and gathering all that data. We have an app store that basically allow us to integrate third-party solutions. I know that some of them has been pitching you, and we can communicate our solutions and APIs with them. They integrate our hardware and platforms. The same can be done with grid BPPs if already are installed, or energy management systems from the utilities. And then we retrofit our unit. We communicate with each other. For example, EDP EMS said, hey, I need you to reduce consumption or feed energy back into the grid. And our technology based on that optimize the different assets. If we need to improve performance, store energy in different solutions, or turn off different loads to provide flexibility to the utility. That's what our technology is allowing us to merge this in front and behind the meter environments into a single one. And that's what we are trying to do. And at the same time, what we are doing with this technology is allowing these software solutions to retrofit our unit, controlling once again the electron, right? In a lot of cases, you are receiving notifications or emails saying you have to do this, turn off your devices, increase the temperature on your thermostat because we are using Zigbee and the thermostat is using different protocols. The great thing about this technology is that we can communicate with a wide variety of solutions. And then if that technology is not talking with us, we really control the electrons, providing a quick shortcut to, for example, even disconnecting the AC or the heat pump or the swimming pool pump if it's needed to save electricity, right? That kind of things can be done with our technology, once again, by providing the platform solution to integrate different software platforms like BPPs, EMSs, or SaaS solutions into the hardware platform.
Okay, understood. Just
one.
Running out of time.
Yeah, sorry. Yeah.
Are you focusing mostly on B2C, right? Not so much B2B.
We're 100% B2B. We are not providing these solutions to end users. We're working with utilities, oil and gas companies, telecommunication companies as a platform, a technology that we
for residential
together.
For residential applications.
We have residential, commercial, and industrial applications actually right now, from small residential units up to factories completely developing technologies to manage, for example, Bimbo facility in Mexico with our technology, managing from electric vehicles, processes, and all their solar arrays. Basically, we are providing them the electricity to manage all these things and charging them for the electricity. So the business model and how we are providing this equipment depends with the partners that we are deploying these units, but we can go from 5 kilowatts consumption up to 10 megawatts.
And the last question very quickly before everyone hates me for dragging this out so long. What's the type of scale that you have on your pilot? So if you had to aggregate all together, how much consumption would you say? How many pilots? Just a quick metric.
For example, we are not limited to that thanks to the partnership that we have with Dell Technologies. So we can do pilots from one unit or ideally.
Sorry, I was asking how many you have right now. How many pilots you have right now?
We are finishing. We have some standalone cases. To be sincere, we're finishing the 1741 SB certification of the units to be able to deploy the pilots at larger scale. And the larger one is with Dell Technologies and Tokyo Electric for 10,000 units altogether.
Okay.
That it's signed, but it's not deployed yet. And also Innova project, we won the award with Innova to be the energy management solution with them. But the city is not there yet. Right? So.
Okay, thank you, Ignacio.
Thank you.
Okay, we passed the time. You were the last one to pitch, Ignacio, so you had extra time.
That's great. Thank you very much.
Yeah, thank you so much. We'll let you know the results in the next weeks. Okay.
Thank you very much. Have a nice day. Bye.
Thank you. Bye. Okay, so we are done. The first day is over. Thank you everyone for being here and for collaborating. So yeah, it was very intense. Tomorrow we have also like 4 hours of pitches, and have a good rest and see you tomorrow.
Thank you, Margarita.
Thank you, everyone.
Thank
you. See you tomorrow.
Bye-bye.
João,
E essa informação, que é para eu poder falar mal toda a gente.